I added some plasticizer, and when the slump obtained 100 mm, then we can compare these admixed concrete with control concrete, not before that. Here the slump was 10 mm before adding the admixture. We cannot compare this concrete with this concrete. Why? Because the workability will be different, their compactability will be different, their strength property will go, and this concrete you cannot compact also. So you need you need to enhance its workability parallel to in comparison with control, that is 100 mm. So if you see that without even after reduction of paste content, I am getting the same workability. So first part reduces paste content without affecting workability. I think it is clearly understood. This is a one step. The other step is change in water cement ratio. Here what I will do, I will not change the cement content. Cement content will remain same, 310, what we put in control mix, that is 300. If I reduce water only, from 200 to 160, the water cement ratio has been changed. Here water cement ratio remains constant, 0.645, and control is 0.645. The second one is water cement ratio has been reduced to 0.51. Paste content here also being reduced from 2984 to 0.2584. The slump already goes down to 20 mm because I cut some water. The strength is 35 mm, but not now. If I add admixture and then make equivalent control slump 100 mm, and if we fill the cube with this concrete with 100 mm slump, then we only can compare this concrete with the control concrete. So what is happening? The one line has to be understood very clearly. Everybody says that it is a water reducer, but my experience says it is a water reducer 100%, but my experience says it is a paste reducer also. This is a very important point to mind, because in my further slides, when I will discuss some topics, the paste content will act mainly. So to understand all the aspect, paste content reduced and workability will same as that of control. Now we can compare admixed concrete with control concrete. This is the theme of these slides, that reducing paste content without affecting workability, not only water content. Here I have reduced paste, cement as well as water. Here I have reduced only water. But in both cases, we have reduced water content also, we have reduced paste content also. It is rather better to say admixture is paste content, paste reducer, right? Next slides. This is the two things what we did. The first left side, no change in water cement ratio. As we did not change water cement ratio, the pore size will remain same in its unit volume. The diameter of the pore will remain same because the water cement ratio is same. Total pore volume is reduced. Why? Paste volume is reduced. Now it is very clear to understand why total pore volumes is reduced. Where the pore exists in the cement paste. So paste is reduced, so total pore volume is also reduced. Aggregate cement ratio is increased. What is aggregate? What is the concept of aggregate cement ratio? Aggregate cement ratio actually signifies how much paste content or aggregate content in your mix. Higher the aggregate cement ratio means higher the aggregate, because yield is 1000 liter. If I increase our aggregate, definitely the cement paste has to be reduced. So in that case, aggregate cement ratio is increased because it reduces paste volume and increase aggregate volume, because we have to maintain yield also. Slight increase in strength may be observed, though the water cement ratio are same, but due to higher aggregate cement ratio, you can get little bit of more strength. Sorry. Yield stress and plastic viscosity also being reduced as compared to the control concrete. This is the first. And when we change in water cement ratio, here pore size will not remain as that of control. Why? Because the water cement ratio has been reduced. Pore size is reduced in its unit volume. As the paste volume reduced, total pore volume is also reduced. As the paste volume is reduced, aggregate cement ratio is also increased because paste is less and aggregate is higher. Adequate increase in strength in observed. Here, two things are happening. When we reduce water content, water cement ratio is being reduced, aggregate cement ratio is being increased. The earlier cases, water cement ratio remained constant, but little bit of change in aggregate cement ratio has been found, and it is in increasing mode. Yield stress and plastic viscosity also being reduced. Now it is very clear. This is the gist of my previous slides. Actually, it reduces paste content. Again and again, I am emphasizing this word, paste content, reduces paste content. Actually, it reduces paste content without affecting the workability of the mix. Few beneficial effects in fresh concrete. These slides are very basic slides. It is not for those who are expert. It is for those who are newcomers to join today and with us. So dispersibility and workability is increased. You have seen it, because increased means when I cut water, it has been reduced. But when I add admixture, it is giving the increase in workability. Dispersibility and workability retention, everything, everybody knows it, that slump retention, 2 hours, 3 hours, whatever maybe it is maintaining. Rheological behavior suitable for pumping. What is rheological behavior? Rheological behavior, we can measure the rheology because it is a shear thinning material. Concrete is a shear thinning material. When we shear the concrete, when we mix the concrete, its viscosity gets reduced. But when we stop mixing, slowly, it gains its viscosity what it was earlier, before start. So this is called thixotropy. Thixotropy is also there. And when we go, discuss about admixture, then one pseudoplastic VMA will be added to the admixture to compromise the thixotropy and pseudoplasticity both. So this is the role of VMA. And setting time, you also know that setting time is little bit of increase as per IS 9103. Then the control concrete, when we introduce admixture, setting time 1 plus 1 hour plus 1.5 hour, it is given in table 1A of IS 9103, and yield also remain constant, right? Few beneficial effect in hardened concrete. What is happening? Strength, both compressive and flexural strength, that has been discussed in my first slides. And then durability. If you go with durability, alkali silica reactions has been reduced with chemical admixtures. How? Now you know that paste being reduced without affecting the workability paste. So sulfate, where the sulfate exists is in the cement, and cement is a part of paste. Paste has been reduced means sulfate has been reduced. So alkali silica reaction has been reduced. Sulfate attack. Sulfate attack also same, sulfate is reduced. Carbonation is also being reduced because calcium hydroxide content remains in the paste and paste volume being reduced. Heat of hydration reduced because paste volume reduced. Chloride penetration reduced because when we change water cement ratio, its pore refinements and grain refinements both are taking place. So it is giving impermeable concrete. So chloride penetration will also be taken care. Water permeability also same thing. Water permeability is also reduced. Dimensional stability also improved. Drying and thermal shrinkage, fridge thaw cycle, creeps, all are because of reduction of paste content. Reduction of paste content. That is why I told before that paste content concept is very important to understand all the properties. Apart from above, it makes the mix economic as well as environment friendly, because our cement content is less, carbon footprint also getting less. So that is why it makes environment friendly. This is a few basic terminology and significant with cement admixture interaction. We'll discuss structure of PC molecules and their types and generations. Then what is called flokes or agglomerates. And when admixture is introduced, there is a word will come later, which is called adsorption. AD, not AB. Adsorption, D means Delhi. Adsorption of molecules on cement particles. And when adsorbed, when the molecules, polymer molecules will be adsorbed in the cement particles, it will provide Coulombic repulsions. It may provide steric hindrance repulsions. All we will discuss. Then very clearly it could be understood. So interstitial solutions. What is called interstitial solution in admixture technology? Interstitial solution is nothing but a space nothing but a space between two cement particles in which some pore fluids remains, where the accumulations of all ionic species uh, collected there, like sulfate ions. First, sulfate ions, sulfate dissolution will take place. Then calcium dissolution will take place. Hydroxyl ion dissolution will take place. Silicon ion dissolution will take place. Then PC molecules, some PC molecules also will be resting in the interstitial solutions also. So these are the very important aspect of admixture technology to understand what is called interstitial solutions. Adsorption of PC molecules on cement surface, sitting. That means it is a cement particles. This is called adsorption. Suppose it is a molecule, It is just sitting. Not it is penetrating. It is called absorption, and it is called adsorptions. This is the difference between adsorptions and it will not penetrate. It will just sit and imparting the charges to the cement particle. Cement particle resultant charge is positive, and admixture resultant charge is negative. And it is called, this charge density is measured as a zeta potential, which is measured in millivolt. So I will not discuss all these. It is a separate chapter. Zeta potential. So this is called adsorption, and this is ionic and Coulomb repulsion, which is called zeta potential and charge density. And some PC molecules where you will find some branch chains. Suppose this is a trunk polymer, and this is a branch chains. This is a 90-degree to the. This is a main polymer, and in which some branch chains are graphed, like comb structure. Comb में कैसा होता है? This is a one side of, and the other is a comb structures. So these comb structures will provide steric repulsion hindrance. And rheology, already I told that it is a shear thinning properties, which includes two rheology parameter, which is called thixotropy. Thixotropy comes from concrete, and VMA will give pseudoplasticity. So it is a very, very fine tuning, or you can say fine combination or compromisation of pseudoplasticity and thixotropy. Thixotropy is a shear thinning. Pseudoplasticity is also shear thinning. But when the shear stress is withdrawn, in pseudoplasticity, immediately it will gain the viscosity. Thixotropy means it will thin the concrete, but when the shear stress is withdrawn, it will slowly gain. It will take some time to gain its viscosity. So it's a time dependent. Pseudoplasticity is independent of time. This is the only, but the function is same. Shear thinning. This is the few admixture molecules and their structures. See, types of admixture molecules and their chain length, charge, and graft density. In late 80s, which is called first generation admixture, the name is lignosulfonate, LS. It is called first generation. It came late 80s. It is simply a linear chain polymer, which is having charge density, negative charge. It contains some negative charge, and water reduction is low. Water reduction is only 8 to 10%. Late 80s, it was being used. Then, when mid 90s, we got SMF, sulfonated melamine formaldehyde. It is called second generation admixture. It is also having a linear chain, but this chain is little bit of greater in length in comparison with lignosulfonate, and charge density is also far better than that means zeta potential is higher in comparison with lignosulfonate. It is having higher zeta potential than lignosulfonate. So its water reduction is up to 22%. Its water reduction is 10%. Then we found SNF that also came in mid 90s. In few places, early 90s also, because I handled 1992-93 in my first job in Tata Steel as a concrete technologist. There we have gone lime calcining plant foundations, where you have we have used a retarder, RP264 phosroc made RP264 retarding plasticizer. So in that case, is little bit of it was a combination of lignosulfonate as well as SNF, and some retarder is also there. So in 92-93, I personally used these admixtures. It is also having linear polymer as well as charge density. Its water reductions up to 20%. And last, what is called with third generation and fourth generation, there is a gap. There is a little bit of difference between third and fourth generation. I will discuss what is the difference between these two. But the basic molecules will be like this. It is a comb-like structure. See, in comb we found in. Let me take a comb, then I will make it explain. Just a minute. It is this type of structure. You see the blue line is a trunk polymer, which is called trunk polymer. Suppose it is a trunk polymer in which some branch chains are grafted. See, and you see there are two densities of graft. Here the densities are less, numbers per unit length is less, this, and here the graft density are denser. The number
थोड़ा सा पीछे कीजिए, दिख नहीं रहा।
अच्छा,
थोड़ा सा
अभी ठीक है,
थोड़ा ऊपर कीजिए।
अभी ठीक है। This is a trunk polymer. This is a trunk
and participants polymer. Can pin his video, Kargupta sir's video, pin करेंगे तो बड़ा दिखेगा. What he is trying to explain is
right. Abhi it is visible to everybody. Now it is visible to everybody.
Yes, sir. Visible.
Yes, sir. Yes, sir. Yes.
These are the branch.
Visible, sir.
These are the branch. Not visible.
No.
It is not visible.
Visible, sir. Visible.
Okay. No. Few people are saying visible. Few are not. Okay. See, it is basically a comb structure, right? So in which you can see the trunk polymer and some branch chains are grafted here. And you can see the graft density is different from here to here. It is a low density, and here to here high density. High density means number of branch chains per unit length. Here is higher, here is lower. This is called graft density. And the charges are lying here. These charges are lying, what is called zeta potential. These charges are lying in the trunk polymer. This is the shape of a PCE polymer. Now, what is the difference between third generation and fourth generation? Third generation means this PCE polymer will act in one direction. It is a water reducer, then it is a water reducer only. Right? It is a slump retainer, then it is a slump retainer only. Some hybrid molecules are there, little bit of it is high, it is fourth generation. Water reduction is also there, slump retention is also there. That means what I am doing, more and more functionality are graft in the main polymer chain. Sometimes maybe it will come that it is a water reducer, it is a slump retainer, two functionality. It is a rheology modifier. It is a corrosion inhibiting properties also there. So these are called when more than one functionality will be there in one polymer. It is called fourth generation. And it came early 2000. This is the structure and, structure of the molecules. And let us, because I will discuss today, because nowadays SNF, you also know that very few places SNF being used. In southern part of India, in western part of India, in little bit of eastern part of India, still few places SNF being used. Now majority PC molecules are being used in all over India, pan-India. So PC molecules, their chain structure, charge density, graft density has been discussed. But here the key word is, it is a very steric. Steric. What does steric means? The word steric comes from the word structure. Steric, it is a very huge molecule, bulky molecule. It acts on its momentum. It acts on its branch chains. It acts on its trunk polymer. huge molecules. Molecular weight is far, far better than lignosulfonate, sodium naphthalene sulfonate, and sodium melamine sulfonate. The key structure, admixture, the key point was paste reductions. Here the key structure we have to take in our brain, that is the PC molecules mean it is a steric structures, right? So we have basically, at present, we have basically three kinds of PC molecules. One is HRWR, high range water reducer molecules. Here, more length of side chains with low graph density. You also know what is low graph density. The graph chains numbers per unit length is low. So it is low density, but side chain length will be more. The longer the side chain length means ki this from this point to this point is the length, right? If the length is more than this one, the water reduction capacity will increase. It depends, water reduction capacity depends upon the length of the side chains, not the graph density of the side chains, length of the side chains, right? More the length of the side chains will give more and more water reductions, right? And SR molecules, slump retainer molecules. Slump retainer molecules, you will find the length of the side chain will be shorter, very shorter, but their graph density, the graph density will be very high. The density will be very high. They are very close to each other. The number of side chains per unit length is very high. So it requires what it requires? It requires graph density, not side lengthing. Hybrid molecules is the compromisations of these two, because it is giving water reduction as well as slump retention. So moderate chain lengths with moderate GT. The two more key features of the molecules here, two more features. Adsorption of the molecule, already I discussed that it is just adsorbed. This is adsorbed like this, not absorbed. This is an adsorptions and imparting cement particle negative charges. Adsorption of molecule, actually what it does, it is imparting some negative charges, cement particles becoming negative charged by the adsorption of PC molecule. How? Because PC molecule is negatively charged. When more and more negative charge sit on the cement particle, the cement will also become a negative. Simple. And here the main word is faster absorption rate. It is faster absorption rate. Faster absorption rate will depend the graph density. This is very important parameter to understand molecule features. HRWR, the graph density is not very high, lowest. Then hybrid is moderate, and slump rate graph density is very high. So though the slump retainer is a small molecules, molecular weight maybe it will be lesser than, it is not like steric like HRWR, it will absorb in late because of high graph density. So higher, faster absorption rate in case of HRWR is very high, then hybrid, and then SR. This will this property in recipe making, this concept will very important. Rheology modifier, I already told that it is a compromisation between pseudoplasticity and thixotropy. Retarder, hydroxycarboxylic acid of sodium salt. You know that sodium gluconate, all are knowing that now. It's not a very secret. Sodium gluconate being used in gluconic acid and sodium hydroxide, when reacted, sodium gluconate is produced. It is a sodium salt of carboxylic acid. This carboxylic group is important. Hydroxy group is giving hydroxyl group is giving retardation, as well as carboxylic acid is also increasing water reductions. So it is also it can also act as a little water reduction as well as retarding capability. So there may be so many salts like sodium tartarate, sodium citrate, citric. These are all organic acid. These are all hydroxycarboxylic acid, in which one you will find a hydroxyl group. In other ring you will find a. So it is called hydroxycarboxylic acid of sodium salt, sodium citrate, sodium tartarate, sodium gluconate. So many salts. So mainly we are using sodium gluconate, and dosage level and solubility is most important for sodium gluconate. Dosage level and solubility, if you give more and more retarder, then it will not set tomorrow, next day it will not set. So we have to, dosage level also depends upon its solubility level. So it is better if you take say in recipe you are giving 4% of sodium gluconate, so at least 8% of water is required to make it soluble. See, actually, practically 58% solubility for the gluconate, but we do not take that much of concentration in the admixture formulation because some other molecules will be also over there. In winter, sedimentation also takes place. So that is why 3 to 4% gluconate is enough, because if you want longer slump retention, then you have to provide slump retainer molecules. Then we are incorporating some biocides to make its shelf life longer. Then you know that all molecules are a little bit of acidic in nature. It is pH adjuster, some sodium hydroxide, something like that. If we go and adding, then pH should be a little bit of higher. Actually, it's pH less than 5. But in IS 9103, it should not be less than 6. So you have to incorporate some, sodium basic materials to make it pH little bit of higher. And defoamer also, that it is a surfactant. PC molecule को अगर आप हाथ में लेंगे, कोई भी PC raw PC molecule को, not modified, not formulated PC molecule, and if you अगर आपका हाथ में थोड़ा सा पानी है और उसमें आप PC molecule ले लिया और ऐसा squeeze किया आपने, if you squeeze it, you see that it will be working as a foam. It will be working as a soap. So it is a surfactant, so defoamer has to be added. And some non-sticky agent, there's some non-sticky agent is also available in the polyoxyethylene oxides type non-sticky agent is also available in the market. Some companies are incorporating, and some micro air also some companies are incorporating, but depending upon the situation. It is not very desirable, micro air, because PC is also having a surfactant, so it will reduce the surface tension of the water. So automatically some air bubbles will be generated, even if you not mix any micro air. So in that case, some cases where the CSS is very harsh, angularity index is very high. If you take your CSS and squeeze, you will feel that your finger will be hard. Maybe seems blood coming. So angularity index very high. In that cases, you can incorporate little bit of micro air, not macro. There are two kinds of air available in the market, but it is better. It is better to use. Sorry. It is better to use micro air because the drop in strength is less. Suppose if you use macro or if you use micro, in both cases, you will see that some drop in strength will be there. But if in case of micro air, you will find less drop in strength. So these are the components of the formulations, recipe. And this is the mechanism of action of what is the flux. Flux means, as you know, that cement particles is having positive charges. And this positive, one cement particle having this side positive, maybe this side negative. How? Suppose C3A, C3, what is C3? What is C? C is the calcium. Calcium is positively charged. Alumina is negative. Calcium silicate, calcium aluminate. So all these are positive and negative charge. Suppose C3A, this in here, this part of C, this part of A. Another C3A will be joined because alumina part will connect with C. This is C, this is Al, and this is C. C and Al will attract. So this kind of weak attraction is called van der Waals force of attraction. It is happening when water is added to the cement particles. The cement particle will start making flukes in which some water will be trapped. This is a cement particle, this is a cement particle in which some water will be trapped. Suppose this is a particle in which, in between, when it will make a fluke around, like this is millions of flukes are there. So in between these flukes, some water will be there. This is happening in cement system when water is introduced into the cement first. Now, what is happening when admixture we are putting? These admixture are adsorbed to the cement particles and making all cement particles negative charged. When all the cement particle will become negatively charged, for similar charge, they will start repelling each other. When they repel each other, these entrapped water path to escape out. See, here adsorption takes place. Here you can see that all cement particles are far away from each other. But the first picture, all particles are very close to the other particles. Here, admixture is adsorbed. You will see this negative charge is there. This negative charge repelling each other. These entrapped water, which was not available to make the aggregate and sand wet. Now this water is being released and it can make wet other dry aggregates and sand. That is why workability increased. This is a very simple working principle of admixture. Now let us go with different. This is a diagram. First, I will show what is called adsorption and how the dispersion takes place. This is a very interesting slides. Please see. Now I am incorporating some admixture. I am addition of first generation admixture. Say I am lignin sulfonate. When lignin sulfonate or SNF or SMF, we are incorporating in this. Here is the blue part is the interstitial solutions. I told the space between the two cement grains is called interstitial solutions. This is filled up with some pore water, some ionic species accumulations are also there. Some dissolution of ion takes place and accumulate here. So in that case, what will happen if I introduce a admixture? See, this is an introduce. I just introduce a admixture. These admixture are negatively charged functional groups, provide water solubility and affinity to positively charged. Now, these admixture molecule will be attracted towards the cement particle. Why? Because you see where everywhere calcium plus 2, all are positively charged. Now see how the adsorption takes place. This is how the adsorption takes place. No molecule is going inside the cement particle. All are sitting to the cement particle and imparting the cement particle negative charge. Now, nowhere the positive charge is there. Everywhere cement particles are negative. Now they will repel. How they repel? Just I tried. See, now they start repelling. First generation Coulomb repulsion. This is called Coulomb repulsion. Now, if I go with some polycarboxylic ether chains, similar manner, they will come, they will be attracted because it is also having some charge density, negative zeta potential. So it will be attracted towards the cement particles. Now you can see that all blue lines are the side chains. These side chains will prevent a barrier so that the two cement particles cannot come close to each other. See, now they will repel. They will, here, the Coulombic repulsion is not taking place. Here, steric repulsion is taking place. Steric repulsion. I am standing here. My hand is like this. My hand is like this. This is a trunk polymer, and this is a branch chain. This is a branch chain. I am pushing the cement particles apart from each other so that you cannot come close to each other. And all the water which was, trapped inside will release. So this is how the dispersion takes place and Coulombic repulsion, steric repulsion takes place. I think it is very clear to all now. Now, these are all the basic slides for the newcomers to understand incompatibility. Now I am coming to incompatibilities. I have never told incompatibility issue from my previous slides. This is required to understand incompatibility. Even for the newcomers, it is very essential to understand. If you can understand this much of, then you can easily understand what is incompatibility issues, how it is raised, and how we can resolve the issue. Incompatibility, what does mean incompatibility? Incompatibility means may be defined as a lack of expected level performance when given combination of cement is used. Some performance I expected, but I did not get. That is, then we call it is a incompatible. What kind of? I expected that slump retention should be 4 hours. It is giving only 2 hours. Then we will say this is a incompatible. Yeah, it is not giving. It is incompatible. This is incompatibility. Anything you desire are not getting is incompatible. You did not want initial bleeding, but still it goes up to 1 hour. Incompatible. You want early strength, you did not get early strength. Incompatible. You want good yield, so you are not. Your concrete is becoming over yield. Incompatible. Some air entrainment is there in admixture. Incompatible. This is called incompatibility. Poor slump retention. You wanted 4 hours. You are getting. You wanted good initial dispersions. The slump अच्छा नहीं आया, 100 भी नहीं आया. Incompatible. So what you expected when you did not get that, then we call it is an incompatibility. Very simple. Incompatibility का और कोई मतलब नहीं है. हमको जो मिलना चाहिए था वो नहीं मिल रहा है, तो incompatible कह देंगे. सीधी बात. ऐसा नहीं है कि incompatibility के लिए ये पैरामीटर दिखनी है, वो पैरामीटर दिखनी है. इतना ही इसमें ही restricted है. Anything which you wanted you did not get, then is incompatible. But other admixture is giving. It is more compatible than your admixture. Then we start calling like this. Your admixture is little bit of better compatibility compared to these admixtures. So these are the performance indicator: flush setting, false setting, poor slump retention, over retardation, bleeding and segregation, low early strength, air entrainment. And factors affecting compatibility: composition of cement, C3A content and its reactivity, tricalcium aluminate content and its reactivity. I would say the reactivity part is more than C3A content important. Reactivity is important. C3A reactivity is very, very important. And also fineness of cement. If the cement is very fine, then you need to pour more admixtures. Type of gypsum used and their ratio. Type of gypsum, I will come. Next slide may have it. There are 3 types of gypsum. One is dihydrate, the other one is hemihydrate, the third one is anhydrate. Dihydrate means calcium sulfate and 2 water molecule will be attached to them. This is called dihydrate, actual gypsum. Hemihydrate is 0.5 water molecule is there, half molecule is there. And in anhydrate there is 0 molecules, right? This is the difference. One is 2 molecule, the other one is half molecule. Hemihydrate is half molecule, gypsum is dihydrate, hemihydrate is half molecule, and anhydrate is 0 molecule. So when we name them together, we called it gypsum polymorph. Poly क्यों? 3 है इसलिए poly, एक तो नहीं है, 3 है. And in cement, सीमेंट का जो वो है, जो रिसर्च होता है, किसी ने शायद हमने किया नहीं है, बट जो टेक्नोलॉजी बता रहा है, किसी ने प्योर जिप्सम देगा तो सीमेंट बहुत ज्यादा कंपेटेबल नहीं होगा. They need to blend these 2 type of hemihydrate and anhydrate. Otherwise, the dissolution rate of sulfate ions will be affected. I will come. Then alkali content, sodium oxide equivalent, potassium oxide, sodium oxide is important because it is acting as a activator. The reactivity of all reactions, C3A when reacts with water and sulfate, it is giving tricalcium sulfate. You also know that is called a tringite. So it requires C3A, sulfate, and water. With this, out of this, if C3A do not get sulfate, then what it will produce? calcium aluminate hydrate is very dangerous, flush setting. सल्फेट चाहिए, दैट इज व्हाई पीपल्स आर सेइंग जी जिप्सम कम है, आपका सेटिंग बहुत क्विक है, फास्ट है. जिप्सम क्या करता है? रिटार्ड करता है. तो जिप्सम एक्चुअली क्या कर रहा है? जिप्सम इज प्रोवाइडिंग सल्फेट ions to the C3A. I will come. There is a slide, good slide, picture-based slide. You can understand. And also type and amount of dosage HRW are being used. Why amount and type? Because it is, if it is SNF, then the dosage will be different. If it is PC, the dosage will be different. Why? What does amount signifies? Amount signifies if alkali content is very high. Actually, in Indian cement, 0.7% sodium oxide equivalent is there, alkali content. If you go with some other part of like US and Korea or something like, you will get higher alkali content. So higher the alkali content, dosage requirement will be higher. Higher the cement fineness, dosage requirements will be higher. So mix proportion, batching and mixing ingredients also, all are affecting these things. See, now I will come cement superplasticizers incompatibility. See, this is a clinker. You know that C3A is there. It is also positively charged. C4AF is a highly positively charged. C3S is also there. C2S is also there. Dicalcium silicate, tricalcium silicate, tetracalcium aluminoferrite, and tricalcium aluminum. This is a cement part, right? This is a gypsum part. I told that some polymorph has been taken here. It's not only dihydrate, which is called gypsum. Hemihydrate is also taken. We have been taken. Anhydrate is also taken. It is a gypsum polymorph. Role of calcium sulfate. What it does? Dissolution of sulfate ions depends the nature and content of calcium sulfate. I told na, dihydrate will release sulfate very slowly. Hemihydrate will little bit of faster. Anhydrate is very fast. So the dissolution rate is not accounted with only dihydrates. If we go with dihydrates, your cement may directly, quick set or flash set. So you need to go with some combination of anhydrates and hemihydrates, because your rate of dissolution will have to be increased. Otherwise, it's very difficult to maintain the workability. And this is a superplasticizer part. I will introduce superplasticizer and role of alkali. What it does, promotes the dissolution of sulfate ions depending on the nature and content of alkali. कौन सा alkali रखा है, सोडियम रखा है या पोटेशियम रखा है, इसके ऊपर वो promotes the dissolution. हो सकता है कि कैल्शियम सल्फेट हमने डाला, डाइहाइड्रेट डाला और हमने अच्छा क्वालिटी की alkali दी, तो dissolution rates increased, maybe. So now what is happened? You know that it is an interstitial solution where the pore fluids are coming. Now see, when cement is just in contact with waters, immediately what happens? Immediately will happen some sulfate from the gypsum. Calcium sulfate से देखो, आपका gypsum interstitial solutions पे आ जाएगा. What charge it is carrying? It is a negative charge. Suppose I am next part. Now I am introducing admixture. Superplasticizer are coming to the interstitial solutions. They will start fighting. Who will adsorb first to the C3A or C4A? This is a very nice story. They will fight. This is the compatibility, incompatibility issues. Now we have to understand. C3A requires sulfate. C3A require admixture molecule, both. C3A require water also to make tricalcium aluminohydrate, which is called ettringite. If ettringite does not being produced, if only C3A tricalcium aluminate hydrate is being produced, you will not get your workability. Suppose if you see sulfate is not there. Suppose sulfate has not come, and I just release admixture. I just put admixture. What it will happen? All the admixture molecule will sit to the C3A. And no other molecules will be available to sit C4AF, C3S. Why? Because C3 is highly positive charge, it is highly negative, they will be attracted. And C4AF में absorption नहीं हुई, C3S में absorption नहीं हुई, C2S में absorption नहीं हुआ, इसका initial slump ही नहीं आएगा. और जैसे ही यहाँ पे सारा molecule आ जाएगा, C3A के ऊपर सारा admixture आ जाएगा. Now C3A has become negatively charged. Then it will start repelling sulfate ions. They will not allow sulfate ion to sit over there. If sulfate ion is not accompanied with these reactions, tricalcium aluminate hydrate, sorry, calcium aluminate hydrate will be formed, which is flush setting. So your dissolution rate of sulfate is a very important aspect. So it comes from two factors: what polymorph you have used, and what kind of alkali content you have used. So it is a cement researcher work. I do not know. Sahu Saab is there. I think he has a lot of experience in this because he has done too many experiments. He can explain better. So as a civil engineer, I understood these things. Sulfate dissolution takes place, should be there in a particular space. Admixture will go, they will start repelling, and both of the things will add up to the cement particles. Then it will make compatible. अगर both एक साथ जा रहा है, sulfate भी जा रहा है, admixture भी जा रहा है, then all the admixture will not sit to the C3A. Then remaining admixture will sit to the C4AF, C3As, C2As, and it will create a full dispersion of cement. First. Second is few sulfate ions seated to the C3A, and it is having water also. So it will start producing a trinsite. And after 3 days or 2 days, or it will convert it to monosulfate, which is called, in 1 day. In 1 day, monosulfate will be produced, what we call setting. Cement has taken set. So this is the incompatibility issue with SNF plasticizer, right? This is only SNF, not with PC. PC में ये सब नहीं होती है, ठीक है? PC में नहीं होता. देखो जाके C3A का ऊपर बैठ गया है, adsorption of HRW1 molecule. सल्फेट मैंने नहीं दिखाया, सल्फेट भी बैठना चाहिए, तब जाके ठीक होगा. मतलब सब जगह में सल्फेट जाएगा, सब जगह में सब इंग्रेडिएंट पे molecules जाएगा, तब जाके good dispersions होगा. So this is the technology happening inside the mixer, right? So for good compatibility, especially in SNF type, cement should be as follows. We need to control reactivity of C3A as well as faster availability of sulfate ions to the interstitial pore solution. Now it has been discussed. And to make the cement with admixture more compatible, cement should not be very too fine. C3A should be in cubic form. When C3A may form in different shapes. Request, somebody can request to mute, C3A should be in cubic form. There is another form which is called orthorhombic form. Orthorhombic form means, see, this mobile is orthorhombic. How? All the dimensions are 90 degrees, but the length is different. The thickness is that much, this width is that much, length is that much. So it is a orthorhombic. The C3A should not be orthorhombic. If it is orthorhombic, the reactivity will very high. What will happen if the reactivity is very high? All the admixture molecule will be attracted to the C3A only. So it will not give the full dispersion. That is why C3A should be in cubic form. Cubic form is not that much of reactive. If the form is orthorhombic, it is very difficult to accommodate all the molecules to all part of the cement ingredients. So low alkali content. If the alkali content is very high, the sulfate dissolution rate is very fast. Gypsum type of high solubility. That is also to overcome this incompatibility issue. Admixture may be used in 2-pack system. अगर आपके साथ ऐसा हो रहा है, now the remedy comes with SNF, not PC. I am discussing only SNF. अगर आपके साथ ऐसा हो, so what you can do? You cannot do anything because cement is not in your hand. Cement has been produced and it has come to you. In admixture, I will not disclose all the recipe, all the formulations here, because maybe some admixture formulator also sitting and listening me. Some companies are also sitting and listening me. They are putting something, in the admixture. They are putting something into the admixture so that the sulfate dissolution rate will be increased. I'm not taking the name, I know, because I work on that. So I'm not taking the name. They're putting something on admixture formulation so that the sulfate dissolution rate is increased and taking place, right? So in that case, even after the compatibility issue is not, incompatibility issue is not resolved, then there is no other way to go for two-pack system. Very two-pack system. एक HRWR ले लीजिए, एक स्लैम्प रिटेनर और रिटार्डर कॉम्बिनेशन ले लीजिए, लेके आप काम कीजिए, तब उसमें से कुछ आपको कंपेटिबिलिटी आ जाएगी. आप टू पैक सिस्टम करना पड़ेगा. इट्स नॉट वर्किंग बिकॉज मे बी इन दैट केसेस योर रिटार्डर वॉल्यूम will be higher and that is not incorporated in a single pack. So you go with two pack system. This is the remedy for SNF. Now I'm coming cement hyperplasticity. What is the time? Oh, sorry, 20 हो गया. ठीक है, I'm short कर रहा है इसको. Cement hyperplasticity is the incompatibility, especially with PCE type. Now we are 90% using this molecule. Now we should go. And what are the performance indicator? Dispersion time. Very high. Productivity मेरा चला गया. Electric motor का इलेक्ट्रिक बिल खूब आ रहा है. 20 seconds का जगह में 40 seconds ले रहा है बैचिंग प्लांट्स. इलेक्ट्रिक मोटर बहुत इलेक्ट्रिक खा रहा है. ठीक है. प्रोडक्टिविटी चला गया. मिस्टर मुकुंद जोशी का एक वो हुआ था कि हाउ टू रन ए बैचिंग प्लांट. ही टोल्ड दैट 10% अगर हम सेव करेंगे डिस्पर्शन टाइम को तो 16% प्रोडक्टिविटी इंक्रीज होता है. आप लोग भी जानते हैं क्योंकि अगर हम एक TM comes, when TM comes and being loaded, when it goes out, the other TM should take the position immediately. So productivity depends upon the mixing time, dispersion time. Some admixture disperse very slow, so it is an incompatible. I want 2-3 minutes. I want within 20 seconds. What is incompatibility? I wanted it in 20 seconds. It is taking 40 seconds. Your admixture is not compatible. Simple. Your admixture is not compatible. So incompatibility comes. Initial bleeding and its duration. When PC admixture is incorporated, some initial bleeding is coming. Definitely, everywhere, 90% cases. It's not like that कि initial bleeding नहीं हुआ और 3 घंटा में जाके वो 180 mm स्लम दे दिया. कभी नहीं देगा, देखेंगे आप. आपको initially bleeding होगा, but we have to see how much this initial bleeding is resting, is existing. That is very important. Poor slump retention. हमको 3 घंटा मिला, 2 घंटा आया, incompatible. Sudden occurrence of post bleeding. पहले bleeding नहीं था, 1 घंटा में था, शुरू में हल्का सा bleeding था, half an hour bleeding था, 1 घंटा में कोई bleeding नहीं था, 1.5 घंटे से ब्लीडिंग चालू हो गया. ऐसा भी आपने देखा बहुत जगह में. सो इट इज इनकम्पेटिबल. कैसे हो गया यार? स्लम बढ़ गया. स्लम तो घटना चाहिए टाइम के साथ, ये बढ़ गया. सडन ऑकरेंस ऑफ पोस्ट ब्लीडिंग, दिस इज ऑल्सो इनकम्पेटिबिलिटी. सडन पोस्ट स्लम ड्रॉप. आपका स्लम ड्रॉप शुड बी ग्रेजुअल. सपोज आई एम टेकिंग 3 hours रिटेंशन. फर्स्ट आवर इट वाज कोलैप्स, सेकंड आवर इट वाज 180 और थर्ड मतलब 180 सेकंड आवर में और 2.25 घंटा में 2.15 hours, 2.15 hours, 2.15, it is becoming 25. This is called sudden post slump drop. Why it is happening? I will give you remedy. Sorry. Over retardation. You know all what is that? Low early strength for precursed members. Precursed members are railway sleepers. They will cast the railway sleepers. They will put the sleepers in a steam curing chamber. It is a process of 5 to 6, 7 hours, something like that, for taking the lifting loads. And they will cure these sleepers for 15 days or something like that. And then they will take it as a use. So low early strength कम आ गया. नहीं आना चाहिए, इतना आना चाहिए, कम आ रहा है. दूसरा एडमिक्सर के साथ आ रहा है. आपका एडमिक्सर इनकम्पेटिबल है. Air entrainment and over yield issue, you know, air entrainment mix will become puffy, floppy mix hoga. What will happen? So let us discuss. and does not depend too much like SNF upon C3A content, its reactivity, ये सब का ऊपर डिपेंड नहीं करता है। आपने देखा नहीं है कि फ्लश सेटिंग हो रहा है, फॉल्स सेटिंग हो रहा है किसी के साथ, ये सब प्रॉब्लम बिल्कुल नहीं है, क्योंकि ये क्यों नहीं है? Because it works on steric repulsions, because it works on its body by force. Nobody can prevent them. It is not attracting by charges. They are going and by their bulky structures. They have some momentum. So it is working like that, steric. So that is why these kind of issues are not coming with PC. No, in nowhere you will hear that, in no place you will have that in PC admixture it is taking flush set. ऐसा हुआ कभी? मेरा पास हुआ नहीं है, हो सकता है किसी का पास हो रहा है, बट मेरे पास कहीं पे ऐसा नहीं होता है। So factors affecting compatibility, admixture recipe, admixture recipe अगर ठीक नहीं है तो होगा। Proper concrete mix design अगर ठीक नहीं है तो भी होगा। Efficiency of the plant, some mixer index में कोई प्रॉब्लम है, मिक्सिंग ठीक से नहीं आ रहा है, मिक्सिंग टाइम इज इंक्रीज्ड, आपका शोवेल एंड आर्म जो है वो ठीक नहीं है, शोवेल और टाइल्स का बीच में जो गैप होना चाहिए 3 to 5 to और मैक्सिमम 10 mm, that is more 25, 30, 40 mm. Discharge gate is leaked, some slurries is coming out, all the water valves are choked, gearbox is not working, all these mixer issues. These mixer, because I know, because I am working in matching plant, this kind of experience I am having. So ambient condition is also there, how much temperature is there, whether the mixture drum is wrapped by Hessian cloth or not, whether we are maintaining the temperature of concrete or something like that. This could be a compatibility issue. So these are the overall compatibility issue. Now we will discuss all these points and how to dispersion time taken for full dispersion of cement particles, right? Incompatibility issue when dispersion time is more than 20 to 25 seconds. A normal grade. If the grade is higher, then your time will, because water cement ratio is 0.23, 0.35, 0.3, so it will take some time, definitely. I am talking about in 20 to 50 grades of concrete, normal concretes, 20 to 25, 30 seconds maximum. So if it is more than that, then your admixture is not compatible. And if your mixture index is okay, that is also have to be looked on. खाली admixture को ऊपर बोलने से नहीं होगा. That is why I am taking all the aspect. Your mix design should be also well compatible. I will come. Effect, what will happen if dispersion time is more? What would be the effect? Decrease in productivity. 10% and 16% I told. Increase in electricity consumption. कितना होता है मेरे को पता नहीं है, वो तो हमको data मिल जाएगा. And ultimately, what will happen? Rejection of concrete. How? Because you will see that your mix is, when the TM is going out, so somebody will go up and check what is the slump, and he has checked it, and he found that slump is collapse. Collapse means 170, 180. And he checked the slump also. So he told, okay, it is okay. But actually it is not fully dispersed in the mixer. Now it will start dispersing when it will travel in the transit mixer. जैसे ही वो साइट पे पहुंचा, वो ओवर कोलैप्स्ड हो गया. कंक्रीट क्लाइंट ने देखा, भाई तुम्हारा तो भाई सेग्रीगेटेड मिक्स है, जाओ ले जाओ. तो रिजेक्शन ऑफ कंक्रीट होगा. Now you see the how dispersion time affect the concrete industry. Actually admixture manufacturer को ये भी सोचना है. ये पहले भी मैं सोचता नहीं था, क्योंकि I worked as a admixture company only, because I did not work in a RMC plant. Now I am working in a RMC plant, so I know the aspect of RMC, what they actually want. They want lesser dispersion time for higher productivity. They want lesser dispersion time for low consumption of electricity. They want lower dispersion time so that it should not disperse further in the road, when it traveling. So dispersion time is very important. Reasons. Now I come to the recipe. High molecular weight molecules have been used. Maybe molecular weight उतना जरूरत नहीं था. High range water reducer हमने डाल दी. Ratio to WR to hybrid molecules is less. Ratio WR ज्यादा होना चाहिए, water reducer molecule ज्यादा होना चाहिए, hybrid थोड़ा कम होना चाहिए, वो ज्यादा दे दिया. Less percentage of salt hydroxy carboxylic acid content and defoamer. Excess percentage in VMA content. Somebody has put some VMA. So it will take some time now. VMA is there. So it will increase the viscosity. How you will get collapse slump immediately? It will not allow to concrete to collapse even after more and more mixing. So VMA is excess. So these are the point. And water to FA ratio is very less. In concrete mix design, what we have to see? Water to FA ratio, free water to FA ratio. See, actually one concrete mix design is designed for a specific slump and specific period of time. I want 180 in 3 hours. This is the requirement. This is the full and final requirement. No other requirement is there. Cement कौन सा है, एक कौन सा है, वो तो अलग बात है. लेकिन what is the requirement? Requirement is 180 mm slump in 3 hours. Now, 180 mm slump in 3 hours means you have to give high slump in a specific period of time. So if your water content is 140 liters and your sand percentage is 42%, what will happen? You will put more and more admixture, then it will make the concrete incompatible. What should be? Your water should be good quantity, say 165, 170 liters. And sand percentage also should be compatible to the water content. Because higher the water content, you need to take higher sand content also. Otherwise, your mix will segregate. Lower the water content, lower slump के लिए आप water content कम ले सकते हैं, sand content भी कम ले सकता है. क्योंकि हमको 100 mm slump देना है. हमको 160-165 लीटर लेके चलना नहीं है. I can go up to 150 liters. So these aspects also to be calculated. Plant aspect, raw material aspect, as well as recipe. Initial bleeding and its duration. Initial bleeding occurs when admixture is added and stays for a specific period. You also know, everybody knows it. What is the incompatibility issue? May get rejected during pouring if not disappeared. If it is not disappeared, client may reject it. भाई तुम्हारा concrete bleed है, हम नहीं लेंगे. बोल जा, हमारा रोज ही होता है. सब RMC plant पे होता है. कुछ ना कुछ plant से होगा. What would be the effect? Rejection of concrete and involve financial loss. Very simple. यही हो रहा है. What is the reasons of happening and how to resolve? Ratio of water to hybrid molecule is more. Ratio of water reducer to hybrid molecule is more. Then initial bleeding होगा. आपने HRWR ज्यादा ले लिया, hybrid कम ले लिया. आपको क्या करना चाहिए था? हाइब्रिड ज्यादा लेना चाहिए था. WR जस्ट धक्का मार के स्लम को खोलने के लिए जितना देना चाहिए उतना ही दीजिए. ने उल्टा कर दिया. मैंने WR बहुत ज्यादा ले लिया और हाइब्रिड जो रिटर्न करके रखेगा उसको हमने कम लिया. तो दिस इज एडमिक्सचर रेसिपी फॉर्मुलेटर वर्क. दे नीड टू गो. एडमिक्सचर फॉर्मुलेशन के ऊपर इनकम्पैटिबिलिटी इशू 50% डिपेंड करता है. 30% डिजाइन मिक्स के ऊपर डिपेंड करेगा. 20% प्लांट एंड ऑपरेशन एक्टिविटीज के ऊपर डिपेंड करेंगे. सो रेशियो ऑफ एक्सेस ऑफ सोडियम, आपने सोडियम ग्लूकोनेट ज्यादा डाल दिया, इनिशियल ब्लीडिंग हो सकता है. एक्सेस परसेंटेज ऑफ डिफॉर्मर कंटेंट आपने डाल दिया, उतना जरूरत नहीं था, आपने 0.1% ऑफ द फॉर्मुलेशन दे दिया. जरूरत ही नहीं था उतना. 0.07 डालने से ही होता, 0.05 डालने से ही होता. क्योंकि उसमें थोड़ा जो हल्का सा एयर चाहिए, हल्का, दैट विल नॉट किल द स्ट्रेंथ दैट इज रिक्वायर्ड फॉर द गुड रियोलॉजी, वो आपने पूरा भगा दिया एयर को. So these aspect has to be considered. And again, water to FA ratio is more. सैंड कम है और पानी ज्यादा है तो ब्लीडिंग करेंगे ही. हम क्या करते हैं ब्लीडिंग करते हैं? भाई पानी थोड़ा काट ले, थोड़ा 2% सैंड बढ़ा दे, यही तो बोलते हैं ना हम बेसिकली. तो वाटर टू FA रेशियो इज वेरी इंपॉर्टेंट फॉर अ डिजाइन मिक्स. ये कहीं नहीं है कंक्रीट टेक्नोलॉजी. दिस इज माय एक्सपीरियंस. आई एम यूजिंग दिस वाटर टू FA रेशियो. हमको ये देख के चलना पड़ता है. If I make a mixed design of piling concrete, my water to FA ratio will be different. If I make a mixed design ratio for 100 mm slump in 3 hours, my water to FA ratio will be different. Because 100 mm slump के लिए 42% sand जरूरत नहीं है. I think all concrete technologists will believe these things. इसमें बहुत बड़ा rocket science है ही नहीं. Pore slump retention, required slump not found during pouring. Incompatibility issue, concrete get rejected if redosing of admixture not allowed. कहीं पे अभी भी redosing admixture allowed नहीं होती है. लेकिन कोड में लिखा है, I will show you in which part it is written and what to be done. Effects: rejection of concrete involve financial loss. Reasons: ये रेसिपी वाला आप देख लो, लेस ऑफ एसर मॉलिक्यूल्स लेसर है, हाइब्रिड मॉलिक्यूल्स आपने कम लिया, खाली WR से डिजाइन कर दिया, थोड़ा सा एसर मॉलिक्यूल आपने दिया, इट इज अ रॉन्ग फॉर्मुलेशन. सो दीज आर टू बी, ये तो सबके लिए नहीं है, जो रेसिपी मेकर्स है उसके लिए है. आई डोंट नो हाउ मच रेसिपी मेकर्स आर विद अस टुडे. एक्सेस ऑफ VMA कंटेंट आपने डाल दिया, जरूरत नहीं था VMA कंटेंट डालना, आपने डाल दिया तो रिटेंशन चौपट होगा. Water to FA ratio is less. Water is less and FA is, water is less and FA is very high in design mix. High ambient temperature and low humidity, no precautionary measure has been taken. So these are the all reasons. It's not only admixture. Concrete mix design is also held responsible. Ambient condition is also held responsible. So it is not only admixtures कि admixture नहीं कर पाया, हमको हर एस्पेक्ट देखना पड़ेगा. Sudden occurrence of post bleeding. I think all recipe makers have understood ये क्यों होता है. पोस्ट ब्लीडिंग ऑकरेंस देख लीजिए क्यों होता है, अब उसको कम कर लीजिए. रीजंस ऑफ हैपनिंग एंड हाउ टू रिजॉल्व. एक्सेस परसेंटेज ऑफ एसर मॉलिक्यूल्स, पहले बताया था ना कि एसर मॉलिक्यूल्स का जो एड्सॉर्प्शन फेनोमेना है वो स्लो है, वो पहले वो नहीं किया, मतलब एड्सॉर्ब नहीं हुआ सीमेंट पार्टिकल पे. वो 1 घंटा बाद 2 घंटा बाद जैसे ही वो एब्जॉर्ब हुआ, कंक्रीट को ब्लीड कर दिया. मैंने देखा इनिशियली ब्लीडिंग नहीं था, 1 घंटा में भी ब्लीडिंग नहीं था, 1.5 घंटे से ब्लीडिंग चालू हो गई. ऐसा होता है इनकम्पेटिबल. सो रिजेक्शन ऑफ कंक्रीट एंड इन्वॉल्व फाइनेंशियल लॉस. सडन पोस्ट स्लम्प ड्रॉप, जैसा मैंने बताया था कि 2 घंटा में तक था, लेकिन 2 घंटा तक था 180, 2 घंटा में 50 हो गया. This is called sudden slump drop. क्या होता है? लेस परसेंटेज ऑफ एसर मॉलिक्यूल्स, हाइब्रिड मॉलिक्यूल्स. फॉर्मुलेशन ही इसमें एक हो सकता है, इसमें डिजाइन मिक्स उतना वो नहीं करेगा. ये फॉर्मुलेशन में, क्योंकि बाकी फॉर्मुलेशन में आ रहा है, आपका नहीं आ रहा है. तो लेसर परसेंटेज ऑफ एसर मॉलिक्यूल्स और हाइब्रिड मॉलिक्यूल और लेस परसेंटेज ऑफ सोडियम ग्लूकोनेट. सो इंक्रीज करो, आ जाएगा. तो over retardation, setting of concrete get delayed. Incompatibility issue, removal of forms get delayed. Early strength of concrete also may be affected, for which execution speed may be delayed. Rejection of concrete involve financial loss. अगर ऐसा होगा तो वही होगा, सब जगह में यही होता है, फाइनेंशियल लॉस होता है कंक्रीट वाला का. रीजंस देख लीजिए, ये सबके लिए नहीं है, रेसिपी मेकर्स के लिए है. मैंने लिख दिया SR and hybrid slow rate of adsorption. Now how it will work? Low early strength, especially found for high early strength of concrete of precast element. Lifting strength of element not achieved. अब जो उसको लिफ्ट करेंगे उसके बाद ही, उस लिफ्ट करने का टाइम भी अगर नहीं आया स्ट्रेंथ, तो when you are lifting the sleepers it will break. When you lifting the elements, precast elements, it will break. Why they need 24-hour strength? This is because of that only. It should have a lifting strength. It should minimum lifting strength चाहिए उसको, लिफ्ट करके कहीं लेके जाना है क्यूरिंग के लिए. ताकि वो 15 दिन क्यूरिंग करेंगे, 10 दिन क्यूरिंग करेंगे, यूज में ले लेंगे, क्योंकि उसका स्ट्रेंथ आ चुका है. HRWR मॉलिक्यूल नॉट प्रेजेंट इन रेसिपी. किसी ने हाइब्रिड से बना दिया उसको HRWR से ही बनाना है, हाइब्रिड डालना ही नहीं है उसमें. एक्सेस परसेंटेज ऑफ एसर मॉलिक्यूल्स, बहुत ज्यादा एसर मॉलिक्यूल्स आपने लिया. लेस परसेंटेज ऑफ स्ट्रेंथ एक्सेलरेटर. देयर आर 2 kinds of accelerator, strength accelerator, set accelerator. I will not take the name because it is confidential. There is some accelerator which is accelerate the setting time. There is some accelerator which accelerates the strength. Less percentage of deformer कम है उसमें. ठीक है. I think it is the last. Air entraining and over yield issue. Air entrainment होगा तो mix will become soft and puffy, reduces both yield stress and plastic viscosity. It will very fine. It has reduced yield stress and plastic viscosity, and mix becomes very soft. No pumping issue, no occurrence of bleeding and segregations. Everything will be good. What is the incompatibility issue? Drop in both early and later strength. Simple. हवा है तो strength जाएगा. Effects may not comply the strength acceptance criteria described in IS 456/2000 and lead to the destructive testing like code test. यही होता है. Strength नहीं आता है तो फिर हम code test में जाते हैं. It's not only admixture कि एयर एंट्रेंट के लिए वो कॉम्पेक्शन ठीक से नहीं किया साइट वाला ने, हमने डंप करके गया, उसमें सूख गया, पानी मिला के चला दिया, ये भी होता है. जो होता है. आई एम शेयरिंग माई एक्सपीरियंस. इनकॉर्पोरेशन ऑफ बोथ माइक्रो एंड मैक्रो एयर एंट्रेनिंग एजेंट इन रेसिपी. अपने रेसिपी में वो डाला, लेस परसेंटेज ऑफ डिफॉर्मर डाला तो भी हो सकता है. तो दीज आर द 3 prime parameter which can overcome incompatibility issue. Admixture recipe about 50%. Performance depends primarily. कुछ भी होता है तो एडमिक्सचर कंपनी को बुलाओ, इसलिए बुला जाता है कि वो 50% वही करते हैं. जैसे एक कंक्रीट मिक्स डिजाइन का कॉस्ट कितनी होगी वो हम हर थोड़ी देखते हैं, भाई उसमें सीमेंट कितनी है, क्योंकि इज द प्राइम एलिमेंट, प्राइम इंग्रेडिएंट. वो ज्यादा है तो मिक्स कॉस्ट ज्यादा होगा, वो कम है तो कम होगा. थंब रूल. तो एडमिक्सचर रेसिपी वाला को बुलाते हैं और वो आके फिर उसको ठीक करते हैं. कंक्रीट मिक्स डिजाइन के लिए वाटर एंड सैंड कंटेंट वही है, वाटर सैंड रेशियो, टाइप ऑफ सीमेंट, सैंड एटसेट्रा. अदर्स अबाउट 20% लाइक स्टोरेज कंडीशंस. आपके एडमिक्सचर को कहाँ पे स्टोर किया है, क्या वो धूप में है तो धीरे धीरे डिग्रेडेशन ऑफ एडमिक्सचर विल टेक प्लेस, सो परफॉर्मेंस विल बी, incompatibility issue may arise. Batching plant calibrations is not proper, so quantity is going to the mixer in a different quantities. Plant health conditions, mixer index and raw material handling index, जैसे skip bucket हो गया, belt conveyor हो गया, and these are not working. When skip bucket is taking the material, it is, it is क्या बोलते हैं उसको, हिलते हैं और कुछ मटेरियल वहां से निकल के आ रहा है, तो इनकम्पेटिबिलिटी इशू होगा. कहीं सेग्रीगेशन ब्लीडिंग हो जाएगा. मान लीजिए सैंड थोड़ा गिर गया तो वही वाटर और सैंड रेशियो चेंज हो गया. सो दीज आर ऑल 3 पैरामीटर्स आर अफेक्टेड. फॉर गुड कंपेटिबिलिटी, स्पेशली पीसी टाइप, सॉलिड कंटेंट एंड इट्स मॉलिक्यूलर डिस्ट्रीब्यूशन इज इंपॉर्टेंट. वेल अरेंजमेंट ऑफ टाइप्स ऑफ डिफरेंट पीसी मॉलिक्यूल्स. आई टोल्ड हाइब्रिड, WR and SR combination should be good and their molecular weight has to be chosen. Preferably moderate dosage of admixture to be used, 0.6 to 0.7%. Apart from this, if still some incompatibility issue there, same issue. To overcome these incompatibility issue, admixture may be used in 2-pack system. 1 pack may be used UHRWR and VMA combination, and 2nd pack may be used slump retainer and retarder combinations. So in that case, when you tried a lot of trials, but still it is not giving. But you have to see in 3 factors. Your plant is okay, your calibration is okay, your plant health indexes are okay, mixer indexes, raw material handling indexes are okay, mix design is okay, and you did too many modifications, still you are not getting the slump due to some other issues. It's not only happening with cement, somewhere sand is not good. So in that case, you need to go for a 2-pack combination. One is UHRWR and the other is slump retainer and retarder combinations. And performance parameters of hyperplasticizer should be dispersibility, dispersion अच्छा होना चाहिए, rheological behavior suitable for pumping, yield stress and plastic viscosity should be minimum. Dispersibility, retention, whatever we choose, that is we are getting. Formulation should be robust, otherwise it is very difficult. If you change little bit of dose, the performance is changing very widely. This is called the formulation is not robust. Suppose you require 120 mm slump, just you redosing 0.05% to enhance the slump up to 180. जैसे ही आपने 0.05% दिया, वो super collapse हो गया. So the formulation is not robust. Formulation stability, क्या उसमें सेटलमेंट हो रही है, मैक्सिमम डोसेज, लो, मीडियम, हाई, रीडोजिंग, क्या आप रीडोजिंग कर रहे हैं, रिजेक्शंस, टाइम elapsed beyond 3 hours. So this is the things. And maximum dosage of PCE, it is mentioned in at the rate of 1%, but it is not rigid. as per clause number 10.3.3, amendment number 4, May 2013 of IS 456, it is written there. You can go up to maximum 1% PC admixture. But if you require more than that, then you need to get an approvals from the client that you need 1.2%, otherwise slump is not coming, otherwise this problem is still remains. So you can go up to 1.2%, but you need a take, but everything should be good. Your setting is normal, your workability is achieved, your strength is good, then only it can be approved. It is written. Redosing, it is also written as per clause number 5.5.7, amendment number 4, May 2013, IS 456/2000. Rejection of concrete at site when time elapsed 3 hours. ये बहुत सारे कंक्रीट इंजीनियर्स का क्वेश्चंस है कि 3 घंटा जाने के बाद कंक्रीट रिजेक्ट होना चाहिए। मेरा हिसाब से नहीं होना चाहिए, क्योंकि इनिशियल सेटिंग जब तक अराइव नहीं कर रहा है तब तक आप कंक्रीट को आप लेके जा सकते हैं। द मोमेंट इट स्टार्ट्स इनिशियल सेटिंग, यू कैन नॉट टच द कंक्रीट, शुड नॉट टच द कंक्रीट. Initial setting time means dispersed cement particles when they are connected to each other. The moment initial setting time starts. Before that, the initial setting time did not take place. So in that case, you can use your concrete. When the gel particle will touch and started forming bonds between them, you cannot destroy. So initial setting time is important. So in a general concrete, 5 to 6 hours is initial setting time. So if it is more than 3 hours, 3 to 4 hours, so it should not be rejected. आपको अगर डाउट है तो आप ट्रायल करके देख लीजिए, 3 घंटे के बाद थोड़ा रीडोजिंग करके देख लीजिए और चेक इट विद द कंट्रोल कंक्रीट, जो जिसका 3 घंटे का स्लैम्प है उसका साथ इसका रीडोजिंग करके देख लीजिए. So I will not go for this because time is over now. So to achieve my last conclusions, right choice of admixture for specific performance, proper selection of ingredients, mix proportions, concrete mix design, proper storage condition, mixer efficiency I told, and knowledge and application of both is actually required. Admixture and concrete technology. It's not like concrete technology का knowledge बहुत अच्छा है तो admixture का knowledge भी थोड़ा सा gain करना चाहिए, और जिसको admixture का knowledge बहुत अच्छा है उनको भी थोड़ा concrete technology का knowledge भी gain करना चाहिए. Then only is suitable compatibility can be expected, because it is not only admixture is responsible for all the incompatibility issue, there are other 2 factors also responsible. So we need to go for that, and I am concluding my presentations. Thank you for your patient hearing. If you have any questions, queries, please write to us on admin@concreteengineers.org, or you can WhatsApp at 76783197777. If you wish to contact personally, so this is my number, you can note it down, or you can contact with my
You can take screenshot of this, so you will remember the numbers and all.
right. So I am concluding. I will thank all the participants.
Thank you, sir. Thanks for the wonderful presentation. And we have some questions also in the chat box. If you can see the chat box, there are a couple of questions there. Probably
Chat box में दिया हुआ है. अच्छा.
हाँ जी.
क्वेश्चन कहाँ पे है?
Sir, in case participants want to
हाँ, यहाँ पे अगर आप
questions
पढ़ के अगर आप सुना सकते हैं तो अच्छा रहेगा. 1-2 क्वेश्चंस हम लेते हैं, बाकी क्वेश्चंस हम उनको क्वेरी.
सर एक क्वेश्चन था शुरू में, इट वाज अबाउट व्हाट इज पेस्ट कंटेंट, वो आप थोड़ा बता दीजिए.
Paste content is a quantity of cement, any microfines like microsilica, PFA, pulverized fly ash, water, and admixture. It is a combination volume of the paste content. What is paste content? Paste is comprised of 2, 3, 4 materials like cement, microsilica, PFA, water, and admixture. This is a paste content. बाई वॉल्यूम, बाई वॉल्यूम अपने उसको यील्ड ले लेना, बाई वॉल्यूम केजी को अपने स्पेसिफिक ग्रेविटी से डिवाइड करके देख लेना कितना आपका वॉल्यूम आ रहा है,
सर एक इसी से जुड़ा हुआ मेरा क्वेश्चन है, इन स्टार्टिंग ऑफ योर प्रेजेंटेशन आपने बताया वी शुड कीप आवर पेस्ट वॉल्यूम लोअर, but in high grade concrete and like M60 M80 we are making now, so we have no choice to increase the paste volume. तो उस paste volume को हम supplementary cementitious material से बढ़ाएं, what you recommend? How?
See, my question, मेरा जो my point is reduction of paste volume in comparison of what? In comparison of control concrete, where हम admixture use नहीं किए हैं,
नहीं
उसका जितना पेस्ट था उससे कम होगा, ठीक है?
Okay.
अभी जब हायर ग्रेड करेंगे उसका भी तो एक कंट्रोल मिक्स होगा, है ना?
Yes, sir.
उसका भी एक कंट्रोल मिक्स होगा. हो सकता है हमने एम 80 कर रहा है, उसमें हमने ओपीसी ले लिया 600 केजी, माइक्रोसिलिका ले लिया 50 केजी, तो उधर पानी ले लिया हमने 300 लीटर, तो वो हो गया उसका, उससे कम हो रहा है ना, उससे कम हो रहा है. लेकिन हायर द ग्रेड हायर विल बी द पेस्ट कंटेंट, बट पेस्ट क्वालिटी you have to change, because now the transition zone concept will come to in higher grades. ITZ concept will come, because your paste is, if your paste is a porous, if paste is a not very dense, then ITZ will be weaker.
So I believe you recommend the use of supplementary cementitious material.
Supplementary cementitious material, definitely.
The particle size distribution.
Yes, particle size distribution. You can use microsilica, you can use PPC cement, you can use PSC cement, whatever.
And one question is from Mr. Deepak Sharma. Sir, how can be saved concrete at site because recipes in not our control? Probably he's talking about admixture recipe.
क्या क्या बोल रहे हैं आप? एक बार दोबारा बोलिए
सर,
प्लीज.
वो बोलना चाह रहे हैं कि कंक्रीट में क्या चेंज कर सकते हैं हम, रेसिपी हमारे कंट्रोल में नहीं है.
नहीं, उनका क्या दिक्कत हो रहा है?
दीपक जी, if you are there, you can elaborate your question.
हेलो सर.
हेलो हेलो हेलो.
सर सेम प्रॉब्लम हो रहा है कि अगर हम स्लम चेक करते हैं अपने में बैचिंग प्लांट पे, तो अच्छा मिलता है 170 180, और साइट पे जाके हमारा वो कोलैप्स हो जाता है 200 210.
उनको it is a fault of admixture formulation, straight way. It is a fault of admixture. कंक्रीट में ऐसा कोई वो नहीं है कि स्लम बढ़ जाएगा. It is a admixture fault. उसको बोलिए, वो समझ, वो मैंने डिस्कस कर लिया है आज क्यों ऐसा होता है. सडन स्लम, सडन ब्लीडिंग ऑकरेंस, एक एडमिक्सचर फॉर्मुलेटर को क्या करना पड़ेगा उसको मैंने बता दिया है. वो कहाँ गलती कर रहा था वो समझ जाएंगे, वो सही कर लेंगे उसको. It is 100% it is a fault with the admixture formulation.
Admixture can be tailor made at your site. जो आपकी साइट की कंडीशंस के हिसाब से एडमिक्सचर वाला अपनी रेसिपी रीसेट करता है, तो वो आप करवा लीजिए. प्रोबेबली ये है. और वन क्वेश्चन सिद्धार्थ जी का भी कुछ क्वेश्चन है सर, आप.
अच्छा, इधर मैं क्वेश्चंस देख रहा हूं मैं. एक मिनट. दीपक शर्मा जी का हो गया. सिद्धार्थ भाट का कंपैटिबिलिटी ऑफ ब्लेंडेड सीमेंट पीपीसी पीएससी कंपोजिट सीमेंट विथ एसएनएफ पीसी एंड एसपी. If projects where chloride is encountered along with sulfates in soil or groundwater, which admixture and cement is advisable? See, actually when chloride is there, so they definitely blended cement should be used, खास करके PSC, Portland slag cement. Chloride के लिए Portland slag is too good because it is producing not only CSH, calcium silicate hydrate, it is producing CASH, CASH, calcium aluminosilicate hydrate. This alumina, what it does, it catches the chloride and bind with them.
Great.
Right? So सिद्धार्थ जी, तो जैसे ही आपने अगर उस पे PSC करेंगे या स्लैग डाल देंगे, तो it will produce CASH, calcium aluminosilicate hydrate. This alumina will bind the chloride and it will not allow chloride to become close proximity to the steel surface.
Right. Thanks a lot, Satya. Thanks a lot. Hello.
And
Yes, sir. Sir, I have one question, please.
Deepankar, yeah, tell me.
Sir, good evening, sir. Actually, it was a very interesting subject. So you explained elaborately, very nicely, very good, sir. Thank you, sir. My question is that in design calculation, there is how to calculate in water content. There is a latest version. It is mentioned that ki fix WC and then the water content will come depending upon our desirable slump. So there is like that we need 125 mm
It is a
slump, right?
very, Deepankar, I understood your point. It is a very, very good questions from
Yes.
your side. How to calculate the water content? It is a
Yes.
very good questions because IS 10262 is not sufficient to calculate water content in a
Yes. Yes.
sufficient is not sufficient.
Yes,
I
sir.
I would request you and referring you one book that is called SP23. There
Yes.
you will find a table in which the type of aggregates are classified, in which you can get a desired slump के लिए कितना, अगर आपने क्रस्ट सैंड यूज कर रहा है, आपने रिवर सैंड यूज कर रहा है, आपने ग्रेवल्स यूज कर रहा है, कुछ भी यूज कर रहा है आप, तो उसके लिए एक फॉर्मूला है 1/3 WF प्लस 2/3 WC करके, तो वहां से आप कंट्रोल वाटर निकाल लीजिए, ठीक है, कि आपको कितना स्लम चाहिए कंट्रोल. मैं आई एम टेकिंग एन एग्जांपल. सपोज यू नीड 120 mm slump in 3 hours, suppose. So you need to make your concrete collapse.
Yes,
for which you have to design your control concrete first.
Yes,
so आपको अगर एडमिशन देके उस कंक्रीट को कोलैप्स करना है, तभी तो जाके 3 घंटा बाद 120 मिलेगा, है ना?
राइट सर.
तो आपको कंट्रोल कंक्रीट भी तो इनिशियली 230 240 लेके आना है, तो उसमें लिखा है कि 230 240 स्लम के लिए इस किस एग्रीगेट में कितना कितना वाटर लेना पड़ेगा, और वो सारा चीज WF और WC में डाल के आपको आप देखेंगे तो करीब 235 260 लीटर पानी आ जाएगा जी, ठीक है. आप 260 लीटर इज योर कंट्रोल वाटर, राइट? नाउ you take 30% मतलब 30 to 35% तक भी आप जा सकते हैं, राइट, क्योंकि नाउ योर मिक्स डिजाइन इज नॉट restricted to IS 9103 parameter. So you go with 35% of water reductions. 35% of water reductions करके जितना वाटर हो रहा है, that is your admixed water.
Okay.
You understood my point?
Yes sir.
Simple method. ऐसे कोई बहुत रॉकेट साइंस है नहीं. आपको SP23 का हेल्प लेना पड़ेगा. ये IS 10262 is not sufficient to give you exact water content. It will give you exact water. अच्छा, अभी और एक पॉइंट और है मेरा. सपोज आपने कैलकुलेट किया थियोरेटिकली, you want 230 mm control slump, but you did not get it.
Yes sir.
तो वो जो थियोरी है ना कि 25 mm इंक्रीज के लिए 3% और इंक्रीज कर लीजिए, उस हिसाब से मान लीजिए आपको 200 मिला तो 230 चाहिए, तो उस हिसाब से पानी मिला के और एक ट्रायल डालिए. So that would be your control water. From that water you reduce 30 to 35% of water, right? That would be your admixed concrete free water, right?
Yes sir. Okay, thank you sir, thank you.
Thank you. और घनश्याम request for regular basis meeting. अच्छा, ठीक है. I will concrete engineers will try. I am not the authority. Concrete engineers will do definitely. We are doing.
और किसी का क्वेश्चन है तो प्लीज आप पूछ सकते हैं.
Mr. Bipul Singh का क्वेश्चन है, if stock admixture in meter MS tank, any reaction in chemical reaction effective in no nothing. MS tank ही होता है. MS tank में अगर आप कोटिंग करना चाहते हैं तो कोटिंग कर लीजिए, इपॉक्सी कोटिंग कर लीजिए.
सर हम विपुल सिंह. सर उसमें टैंक में एक्चुअली क्या होता है कि टैंक तो ऑब्वियसली बाहर ही रखते हैं, तो उसका टेम्परेचर लो और टेम्परेचर हाई होता है, तो उसी को केमिकल इफेक्टिंग जैसे
नहीं, वैसा कुछ उसमें कुछ
नहीं, उसको शेड में रखना पड़ेगा. अंडर शेड.
देखो, उसमें धूप नहीं पड़ना चाहिए. शेड
के नीचे रखना है, चाहे जो भी
शेड का नीचे रखो, धूप नहीं पड़नी चाहिए उसमें.
आपको
तो आप दुबई में एडमिशन यूज हो रहा है ना, दुबई तो 50 डिग्री जाता है, उसमें कौन सा एडमिशन खराब हो जाता है?
Hello, sir. Sir, one more question is there, sir. सर एक्चुअली कभी कभी क्या होता है, अगर हम हायर ग्रेड डिजाइन करते हैं अबव 50, तो वहां पे अगर मैं समटाइम्स एडमिक्सचर जो मैन्युफैक्चरर है उनको क्या रिफर कर सकते हैं कि वो वाटर रिड्यूसर बढ़ाएगा, सॉलिड कंटेंट बढ़ाएगा? समटाइम्स वो लोग कहते हैं कि आप डोजेस ऑफ इंक्रीज एडमिक्सचर डोजेस इंक्रीज कर दो, जहां पे 0.8 लगना था वहां पे 1% यूज करो, instead of they are not using like solid content, which is better to increase admixture?
I understood. Now let me answer your questions.
Yes.
It is a common concept, market concept. आपको एडमिक्सचर कैसे बेचना है? They do not know actually. एडमिक्सचर बेचा नहीं जाता है कि पर केजी का प्राइस में। आपको एडमिक्सचर बेचना है तो you have to give cost per cubic meter. Admixture cost per cubic meter. Maybe my admixture cost is 85 rupees. Somebody's admixture cost is only 25 rupees. His admixture is being used 4%. My admixture is used 0.5%. Which is cheaper?
Yes.
You tell me which is cheaper. So they have to say कि हमारा एडमिक्सचर का कॉस्ट मत देखिए, वो आपका एडमिक्सचर का कॉस्ट कितना आपका पर क्यूबिक मीटर में लग रहा है वो देखिए। आपका तो कंक्रीट कॉस्ट, आपको तो उसका तो आप बिजनेस कर रहे हैं ना।
Yes, sir.
पर क्यूबिक मीटर कॉस्ट नहीं भरना चाहिए।
Not only sir, admixture companies, user also needs to understand this. That cost per cubic
कौन सा
meter
सीमेंट में हमारा कम हो रहा है, ऐसा नहीं है। वंडर सीमेंट इज अ वेरी गुड सीमेंट। वंडर सीमेंट पे अभी डालमिया सीमेंट इज वेरी गुड सीमेंट। दे कैन यूज फॉर यूजिंग दिस सीमेंट। उसमें सीमेंट कंटेंट कम हो जाएगा, प्राइस ज्यादा हुआ तो क्या हुआ, कॉस्ट पर क्यूबिक मीटर कम हो गया। तो ये कॉन्सेप्ट लेके आना है। वो इसलिए रेसिपी चेंज नहीं कर रहा है। रेसिपी चेंज करता है तो उसको दिमाग में आता है, अरे मेरा कॉस्ट तो बढ़ जाएगा, बढ़ने देना भाई, क्या प्रॉब्लम है, डोसेज कम हो जाएगी।
सर और एक चीज प्रॉब्लम हो रहा है साइड में, जैसे अभी एक सपोज क्रेशर सैंड के साथ हमने डिजाइन किया था, के बाद में सडनली हमने वन क्रेशर एक चेंज हुआ, जैसे सेम एडमिक्सचर के साथ वो क्रेशर का मटेरियल हमने यूज किया, तो उसमें देख रहा हूँ कि जो हम लोग प्योर क्रॉस सैंड यूज किया था और एक आरबीएम सैंड यूज किया, आरबीएम को क्रॉस करके उसमें देख रहा हूँ कि वॉइड्स ज्यादा बन रहा है, मिक्स फ्लॉपी हो रहा है। सेम एडमिक्सचर जब हम प्योर क्रॉस सैंड के साथ करते हैं, स्टोन को क्रॉस करके, उसके साथ कोई मिक्स फ्लॉपी भी नहीं हो रहा है। और
आई अंडरस्टूड व्हाट हैपेंड। एक कोई सैंड के साथ जब वो अपने एडमिक्सचर को कंपेटिबल किया था, हमने वो रेसिपी आज बोला वो चीज, तो उसका एंगुलरिटी इंडेक्स बहुत हाई होने का चलते उसको एयर डालना पड़ा मजबूरन,
राइट,
बाय कंपल्शन उसको डालना पड़ा। अगर जब तक वो नहीं डाल रहा था तब तक उसका स्लम्प नहीं आ रहा था, बिकॉज उसका एंगुलरिटी इंडेक्स इज वेरी हाई व्हेन दे आर connecting and they are producing huge friction which is restricted the flow.
जी,
ठीक है, it increases the plastic viscosity, right?
Yes.
So to reduce the friction, एयर क्या करता है, वो बॉल बियरिंग के काम करता है, वो जाके दोनों का जगह में वो आ गया तो वो कर दिया। आप जो सैंड आप यूज कर रहे हो, दैट सैंड डज नॉट रिक्वायर एयर,
राइट।
सो मिक्स फ्लॉपी बन रहा है, उसमें एयर बबल पकड़ रहा है, तो उसको बोलिए वो नया फॉर्मुलेशन दे देगा। ये होता है, ठीक है, यू नीड टू चेंज योर फॉर्मुलेशन। फ्लॉपी बन रहा है मतलब क्या हुआ है, एडमिक्सचर में एयर डाला तभी तो फ्लॉपी बन रहा है। अब उसको तो आप हटा नहीं सकते हैं, अब तो एडमिक्सचर चेंज करना पड़ेगा।
अब वो मैन्युफैक्चरर क्या बोल रहा है, तुम्हारा सेम एडमिक्सचर है, उसके साथ एयर नहीं बन रहा, इसके साथ एयर थोड़ी ना बनेगा, ऐसे ऐसे जस्ट दे आर डूइंग लाइक दैट।
नहीं, एयर खाली एडमिक्सचर नहीं करते एयर, कभी कभी मैंने देखा है कि एडमिक्सचर में सफिशिएंट अमाउंट ऑफ डिफॉर्मर डाला, एयर तो डाला ही नहीं है एडमिक्सचर में, डिफॉर्मर डाला तो भी एयर आ रही है, तो उसमें कुछ सीमेंट का प्रॉब्लम होता है, उसमें कैल्शियम ऑक्साइड ज्यादा होगा, मैग्नीशियम ऑक्साइड, एक्सपेंसिव मटेरियल बन के।
बट सेम सीमेंट है सर, सेम सीमेंट जब हम क्रॉस सैंड के साथ यूज कर रहे हैं उसमें एयर नहीं आ रहा है। सेम सीमेंट सेम एडमिक्सचर, मतलब
क्रॉस सैंड के साथ नहीं, वही तो मैं बोल रहा हूँ। क्रॉस सैंड क्या कर रहा है, उसकी स्पेसिफिक सरफेस बहुत हाई है एंड एंगुलरिटी इज वेरी हाई, सो मोस्ट ऑफ द एयर मॉलिक्यूल्स, एयर एंट्रीनिंग मॉलिक्यूल्स was adsorbed by the aggregates. It is not found in the paste. That is why आपको मिल नहीं रहा है, वो एग्रीगेट के ऊपर एडसॉर्ब्ड हो गया।
राइट सर,
समझ में आया? जब वो एडसॉर्ब नहीं होगा और पेस्ट में एग्जिस्ट करेगा तभी जाके आपको एयर कंटेंट आएगा, क्योंकि वो बबल पेस्ट में रहेगा। उसको चाहिए एयर, आप जब तक एयर नहीं दोगे अब ऐसे आपको एक एग्जांपल दे रहा हूँ, जैसे मान लो कि आपने फ्लाई ऐश में कार्बन कंटेंट ज्यादा है
जी सर।
सपोज, तो एडमिक्सचर आप कितना भी डालो स्लम्प नहीं आएगा। क्यों? क्योंकि ऑल द कार्बन कंटेंट, जो कार्बन कंटेंट है, कार्बन पार्टिकल्स है, वो सारा पार्टिकल वो एडमिक्सचर को एब्जॉर्ब कर लेता है। नो अदर मॉलिक्यूल्स आर अवेलेबल फॉर डिस्पर्शन ऑफ द सीमेंट पार्टिकल्स।
राइट।
यस यस।
थैंक यू
संजीव सर, टेल मी, संजीव साहब, संजीव साहब बताइए।
सर यू आर ऑन म्यूट सर।
Yeah, sorry. Good evening. Simple
Good
thing
evening.
है, they should understand कि उसका दोनों का मटेरियल जो अभी क्रश सैंड है उसका एब्सॉर्प्शन कितना है। सपोज उसका एब्सॉर्प्शन ज्यादा रहेगा, उसका एडमिक्सचर के साथ ही वाटर एब्सॉर्प्शन हो रहा है, तो तुम्हारा एडमिक्सचर का डोसेज बढ़ने वाला ही है। सिंपल कैलकुलेशन है,
सिंपल कैलकुलेशन,
तो उसमें कोई रॉकेट साइंस नहीं है।
हाँ।
तो वही उन्होंने देखना चाहिए कि उसका 75 माइक्रॉन्स कितना है। इफ 70 माइक्रॉन्स ज्यादा रहेगा तो उसके वजह से उनका कुछ प्रॉब्लम होता रहेगा, या उनको डिस्पर्शन नहीं मिल रहा है, इनिशियल डिस्पर्शन मिल रहा है नहीं मिल रहा है, या रिटेंशन नहीं मिल रहा है, उसके लिए उनको सोचना चाहिए। तो थोड़ा उनको मिक्सेस चेक करके देखना पड़ेगा, मटेरियल क्रस्टाइन का स्पेसिफिक ग्रेविटी हो या उसका एब्सॉर्प्शन वैल्यू जरा चेक करके उनको वापस रीडिजाइन करना पड़ेगा। तो खाली एडमिक्सचर के ऊपर कोई ब्लेम होता है, अभी यही तो प्रॉब्लम है। पहला सीमेंट के ऊपर ब्लेम होता था, अभी एडमिक्सचर के ऊपर ब्लेम होता है। तो आरएमसी वाले को तो किसी को ऊपर तो ब्लेम ढकेलना ही है, इसलिए उसका क्लाइंट उसके ऊपर ब्लेम करता है, तो सबको लेके उसको आगे चलना है। तो अपने को
सबसे पहले एडमिक्सचर कंपनी के ऊपर,
या तो जहां में 4 किलो डालता है एडमिक्सचर, सपोज इतना 2500 kg में, तो ब्लेम वाला कंडीशन कैसा होता है मेरे को कभी समझ में नहीं आता है। सो दैट्स द रॉन्ग थिंग। आई मीन चार पार्ट ऑफ द एडमिक्सचर आल्सो। अभी चलता है, क्या करेंगे। लेकिन सर थैंक यू वेरी मच, आपका बहुत अच्छा प्रेजेंटेशन था, और सिंपल प्रेजेंटेशन, और सिंपल आपने सबको इनपुट्स दिया, विच इज वेरी नाइस, and our team is excellent. So मजा आ रहा है एक्चुअली।
थैंक
ये
यू,
कंटिन्यू।
थैंक्स
सर। सो अभी तो बहुत टाइम हो गया सर, वी विल टेक वन लास्ट क्वेश्चन।
Bhaskar this side. Can you ask any question?
यस
Yeah,
यस
you
सर,
can
यस
ask.
प्लीज प्लीज।
Sir, generally यहाँ पे सारे civil engineer है. Basically, I am working in Gulf or also in Ready Mix India. That time I am seeing huge differences in mix designs. In that time I am sitting in opposite side in ready mix side. I am blaming to ready admixtures and all the things. But I am not checking our material how to gauge. If I am taking in different crushers, is silt is coming higher side, and if I am taking is other crusher, is silt is different. But ready mix is asking is your slump is not coming, or mix is going to floppy, is one person asking like that. But हम लोगों को इंडिया में सोचना पड़ेगा कि हम लोग जो स्लम्प रिक्वायर्ड कर रहे हैं क्लाइंट से और एडमिक्सचर्स कंपनी से, जैसे आपने सर बताया 2 कंपोनेंट, इट्स गुड। हम लोगों ने पहले ही टारगेट करते हैं 3 आवर्स का, जो बेसिकली 3 आवर्स हम लोग रेडी मिक्स में हो या कहीं भी हो। जनरली इफ आई एम प्रोडक्शन इज 5000 और 4000, दैट टाइम ओनली मैक्स टू मैक्स 1000 क्यूबिक मीटर रनिंग इन 3 आवर्स। अगर हम 5000 का प्रोडक्शन करेंगे 1000 क्यूबिक मीटर ही हम लोग 3 आवर्स चेक होता है जनरली। और उसके लिए हम लोग एडमिक्सचर्स को ट्राई करते हैं। दैट टाइम एडमिक्सचर कंपनी इज पुटिंग मोर एसकेपी, मोर वाटर रिड्यूसर, और मे बी इज वाटर रिड्यूसर इन रेडी मिक्स और कंक्रीट। जब हम लोग साइड मैन्युफैक्चरिंग करते हैं, दैट टाइम सेम मिक्स अगर हम लोग सेम एडमिक्सचर लेंगे, दैट टाइम 20 M20 और M15 और M10 और M60 इज रेडी मिक्स, और साइड को रिक्वायरमेंट क्या है कि हमको सेम एडमिक्सचर में काम करना है, इज राइट। और सेकेंड थिंग, if I am working in M10, that time water reducing percentage is taking 25%, and if I am going to 40 C40, that time required more than 35%। क्या हम लोग 25 सेम मिक्सचर्स कंपनी में और सेम प्रोडक्ट में हम लोग वाटर रिड्यूसिंग परसेंटेज है मिक्स डिजाइन में, एक में 25, एक में 30 और एक में 35, क्या एक्सेप्टेबल है जो साइट पे करते हैं? दैट जिसके वजह से एडमिक्सचर कंपनी पे ब्लेम जाता है कि आपका एडमिक्सचर परफॉर्म नहीं कर रहा है, हमारा इसमें आ रहा है, हमारा इसमें आ रहा है, हमारा इसमें नहीं आ रहा है। हो सकता है एडमिक्सचर कंपनी अपना डिफरेंट प्रोडक्ट जनरेट करती है, उनके फॉर्मुलेटर अपने लेवल में डेवलप करते हैं प्रोडक्ट, बट हम लोग जब प्रोडक्ट और क्रेशर अलग अलग चेंज कर रहे हैं तो हम लोग को प्रोडक्ट्स के और मिक्स डिजाइन पे भी ऑप्टिमाइज करना चाहिए कि हमारा स्पेसिफिक ग्रेविटी हो और वाटर ऑब्जर्शन है जो संजीव सर ने बोला वो भी चेंज होगा कि हम ABCD क्रेशर से ले रहे हैं तो इसका ऑब्जर्शन इतना है और XYZ से ले रहे हैं तो इसका, दैट टाइम हम लोग फेसिंग करते हैं। और सेकेंड थिंग, जब हम लोग सीमेंट्स में आते हैं, सीमेंट्स में जनरली अगर हम लोग देखेंगे साइट पे इनिशियल फाइनल चेक करते हैं तो 90 मिनट और 60 मिनट और 90 मिनट और 120 मिनट में इनिशियल सेटिंग जनरली आता है, हम लोगों ने जो देखा है साइट लेवल पे। लेकिन हम लोग ट्राई करते हैं सीमेंट का अगर 90 मिनट इनिशियल सेटिंग है 3 आवर्स और 4 आवर्स, हाँ 2 कंपोनेंट इज ओके, बट सिंगल कंपोनेंट में क्या सफिशियंट है कि हम उसको एक करें, जिसके वजह से सर एडमिक्सचर कंपनी इज पुटिंग मोर वाटर रिड्यूसर एंड मोर एसकेपी और यू आर टेलिंग डिफॉर्मर इज गुड और बैड, इज काइंड्स ऑफ इज रॉ मटेरियल नॉट ए सीमेंट एंड एडमिक्सचर, इज योर सैंड एग्रीगेट, दैट्स व्हाई इज माय क्वेश्चन, इज कैन यू क्लैरिफाई ऑन ऑल क्वेश्चन?
नहीं सर, देखो आपका जो पहले वाला क्वेश्चन था वो मैं क्लैरिफाई कर देता हूँ। वाटर रिडक्शन अगर आप बात कर रहे हैं तो इट इज ए कंट्रोवर्शियल, किसी ने बोलेंगे, आप देखेंगे किसी ने बोलेगा 40% है, किसी ने बोलेंगे 47% है। मेरा हिसाब से पीसी एडमिक्सचर का आई डिड नॉट फाउंड मोर देन 27-28%।
ओके,
आप लोग सुन के वो हो गया है, मैं आपको एक्सप्लेन कर रहा हूँ क्यों कैसे। I am going with IS 9103 गाइडलाइंस। वाटर रिडक्शंस के बारे में खाली 9103 गाइडलाइंस में ही लिखा है। उसमें लिखा है कि आप 307 ±3 kg वाटर ले सकते हैं। तो आई हैव टेकन 310 kg वाटर। पहले वाटर रिडक्शंस की बात कर लेते हैं। आप उतना पानी लीजिए जिसमें आपको 40 to 60 mm स्लाम चाहिए, तो एवरेज आप 50 mm स्लाम पकड़ लीजिए। तो 50 mm स्लाम, 310 kg सीमेंट, और आप एक मिक्स डिजाइन बनाइए जिसमें 50 mm स्लाम होगा, सैंड वगैरह 20 वगैरह सब कुछ डाल के बनाइए। और उसमें अगर आपको 50 mm स्लाम मिल रहा है 310 किलो सीमेंट पे, जितना पानी पे मिल रहा है उतना पानी, मैक्सिमम वाटर 200 आप पकड़ लो, 200 पकड़ लो आप, ठीक है, 200 पकड़ लो। 200 का 30% कितना होता है? 60 लीटर। 60 लीटर हो गया। अगर 60 लीटर 200 से माइनस कर दोगे तो फ्री वाटर कितना हो गया? 140 लीटर, ठीक है। 140 लीटर्स में एडमिक्सचर डाल के आप बहुत मुश्किल से आपको मिल जाएगा 50। सपोज somebody is telling 45%, 40%, आप 200 लीटर का 40% कितना हुआ? 80 लीटर। आर यू एबल टू गेट विथ, जब आप 200 से 80 माइनस करोगे तो आपका फ्री वाटर विल बी 120। आर यू एबल टू गेट 50 mm स्लम? सो वो सब स्टोरी जो है वो सब स्टोरी नहीं सुनाने का है। हमारा वाटर रिडक्शन 40, 50 ऐसा नहीं होता है। साइट पे जो प्रैक्टिकली मिलती है वो मेरे को मिला 27%, 28%, 30% भी नहीं मिला। बट गाइडलाइन इज IS 9103 1999, ठीक है। उसी गाइडलाइन की हम बात कर रहे हैं। अभी आपका पॉइंट पे आ रहा है। अभी आप जो कर रहे हो वाटर रिडक्शंस, आपको एक कंट्रोल कंक्रीट बनाना पड़ेगा। फर्स्ट कंट्रोल कंक्रीट का वाटर कंटेंट कहां से लेना है? आपको SP23 में एक टेबल नंबर आपको याद नहीं आ रहा है, इतना दिमाग अभी तो एज हो रहा है मेरा, तो अभी वो टेबल नंबर याद नहीं है। तो टेबल नंबर से आप कंट्रोल वाटर कंटेंट निकाल लीजिए। और आपको अगर मान लीजिए 2 घंटा 3 घंटा बाद आपको स्लम देना है 150, 160, सो यू नीड टू गो फॉर 230 to 40 mm स्लम, 230 mm स्लम एटलीस्ट। तो आप देख लीजिए कि उस मिक्स में 230 के लिए कितना होगा, दैट डिवाइडेड बाय 0.23, 0.35 व्हाटएवर में भी। आप ग्राफ देख लीजिए, उसका जो ग्राफ है वो ग्राफ से देख लीजिए वाटर सीमेंट रेशियो, सीमेंट कैलकुलेट कर लीजिए, कैलकुलेट करके कंट्रोल मिक्स बनाइए, ठीक है। उस पानी से आप तो 35% भी मिल जाएगा, 40% भी मिल जाएगा। सपोज आपका 300 लीटर पानी में वो आ रहा है, तो 300 का अगर 40% करोगे कितना हो रहा है? 300 इंटू 40, 3 12, 120, 300 120, 300
120 सर
करोगे कितना आएगा? 180 लीटर। if I am not wrong. So you will get a slump. So water reduction, जो water reduction का जो scenario है ना, अगर water reduction की जब हम बात करेंगे, तो हमको कोई एक जगह में स्टिक होना पड़ेगा कि हमको IS 9103 गाइडलाइन, किसी ने इसलिए बोल देते हैं कि 40%, 50%, ऐसा नहीं होता है। वो तो कुछ भी बोल देगा, कल मैं 700 लीटर पानी से बनाएंगे, वहां पे हम 50% कर देंगे तो भी हमारा पास 350 लीटर पानी है, तो उसमें से कुछ भी स्लम्प आ जाएगा। तो वो फ्रीज करना पड़ेगा मिक्स डिजाइन, जो IS 9103 फ्रीज कर दिया है। क्या संजीव जी ठीक बोल रहा हूं ना, कि फ्रीज करना पड़ेगा। 310 kg सीमेंट पानी लेके आप इतना स्लम्प बनाइए और उसमें से पानी काट के देखिए कितना पानी में उतना स्लम्प आ रहा है।
राइट सर, वही मैं भी
ये हो गया। तो उसके बाद मैं एक चीज बोलूंगा आपको, बस सेकंड पॉइंट डिजाइन मिक्स की, और कुछ नहीं है डिजाइन मिक्स में। एक तो वाटर कंटेंट है, दूसरा है सैंड कंटेंट। मैं इसी का ऊपर जोर देता हूं। आई एम 99% सक्सेसफुल। आप सैंड कंटेंट डिसाइड करोगे आपका स्लम्प के ऊपर, पोरिंग स्लम्प के ऊपर। अगर आपका पोरिंग स्लम्प 110 mm है, 120 mm है, गो फॉर 36-37% स्लैब। ठीक है, आपका पोरिंग स्लम्प अगर 180 आउट, देन 41-42% स्लैब, बिकॉज यू नीड टू इंक्रीज वाटर कंटेंट एज वेल एज स्लम्प कंटेंट। अच्छा, अभी ये एक स्पेसिफिक पीरियड ऑफ टाइम के लिए है। मान लीजिए आपने 3 आवर्स के लिए डिजाइन किया, कैन वी यूज दिस फॉर लोअर स्लम्प? नो। क्या प्रॉब्लम होगा वो भी मैं बता देता हूं आपको। अगर आपने डिजाइन किया 3 आवर्स के लिए 180 एंड इट इज गिविंग वेरी गुड कोहेसिव मिक्स, ठीक है, और उसी मिक्स को आप 120 पे जैसे लेके आ जाओगे, द मिक्स विल बिकम स्टिकी बिकॉज इट इज हैविंग हाई परसेंटेज ऑफ सैंड, इट मे नॉट बी कम्ड आउट। अगर आपने 120 में डिजाइन किया तो एडमिक्सचर बढ़ा के आप 180 में डालना चाह रहे हैं, दैट मींस सैंड परसेंटेज इज लो। सो डिजाइन मिक्स ये दो चीज के ऊपर डिपेंड करेगा, आपको कितना वाटर कंटेंट लेनी है वो स्लम्प के ऊपर होती है। आपको स्लम्प और सैंड कंटेंट उसके साथ एडजस्ट करना पड़ेगा। इफ योर स्लम्प इज हाई 200, you go 42-43% sand. If your slump is 120, you go 36-37%. If it is 150-160, you can go up to 38%. This is a thumb rule. अभी 1% ट्रायल करके आप एडजस्टमेंट कर लीजिएगा। वो हम यहाँ बैठ के, क्योंकि आपका सैंड का नेचर क्या है आई डू नॉट नो, दिस इज अ थंब रूल गाइडलाइन। आप इसको मानिए, उसके बाद आप कीजिए। आपको कंट्रोल के साथ कंपेयर करना है वाटर रिडक्शन। आप वाटर, मैंने बोला ना, कंट्रोल में जितना पानी आगे बढ़ेगा, तो कोई एक कंट्रोल में 40% मैक्सिमम हो रहा है, तो दूसरा कंट्रोल पे मान लीजिए पानी बढ़ गया, उसमें 50% भी हो सकता है। So you have to freeze a mix design for water reduction calculations. So this is my answer.
Okay sir.
Yes Sanjeev sir.
सर थोड़ा सा ऐड करना चाहता हूँ इसके अंदर।
हाँ, why not?
इधर अपना IS 10262 क्या बताता है, पहला पानी फिक्स करो, बाद सीमेंट लाओ, बाद में उसके ऊपर एग्रीगेट लाओ। इफ यू कंपेयर विद द ASTM और इवन इफ यू कंपेयर विद द DOE मेथड, वो रिवर्स करता है। पहला वो एग्रीगेट करता है, उसका एग्रीगेट का कैलकुलेशन करता है, उसके ऊपर स्लम कैलकुलेशन आएगा, उसके साथ तुम लोग आगे चल के जाएगा, वाटर सीमेंट रेशियो, एवरीथिंग इज देयर। So if you compare with the ASTM or ACI method or IS code method, IS code में एक ही मेजर इशू मेरे को लगता है कि everything is correlated with the strength first and then workability। मैं तो maybe I am wrong, लेकिन I can say that कि IS 10262 से मैं डिजाइन करता हूँ RMC कैलकुलेशन के लिए या RMC कंक्रीट के लिए। तो मेरा RMC में पहला मेरा एम क्या है, वर्केबिलिटी एंड रिटेंशन। उसके बाद में स्ट्रेंथ क्राइटेरिया, स्ट्रेंथ तो मेरा आने वाला ही है। जब मैं सीमेंटेशियस कंटेंट पकड़ूंगा, मैं वाटर सीमेंट रेशियो है, तो मेरे को स्ट्रेंथ का कोई प्रॉब्लम नहीं है।
आई एग्री।
तो मेरा फर्स्ट टारगेट है कि मेरे को वर्केबिलिटी चाहिए, प्रॉपर रिटेंशन चाहिए, पंपेबिलिटी चाहिए, या मेरा सेग्रीगेशन भी होना चाहिए। बिकॉज ये जो चीज है ये ज्यादा गवर्न करती है मेरे RMC कंक्रीट के लिए। जो 3 घंटे में अंदर जो 50 प्रॉब्लम्स क्रिएट होने वाले हैं और रिटेंशन और गाड़ी रिजेक्ट होने वाला है, ये सब मेरे को पहला उसको स्टॉप करना चाहिए या उसके ऊपर मेरे को काम करना चाहिए। उसके बाद मेरा वाटर सीमेंट रेशियो बराबर है, मेरा सीमेंटेशियस कंटेंट बराबर है, मेरा फ्लैश कंटेंट बराबर है, सब कुछ। या PSC में कर रहा हूँ, व्हाटएवर आई एम यूजिंग द सीमेंटेशियस मटेरियल, मेरा आने वाला है स्ट्रेंथ।
एग्जैक्टली वही बोला मैंने।
तो बेसिक मेरा कंसेप्ट यही है कि मेरे को
ठीक,
वर्क, और उसके लिए मेरे को मदद कौन करने वाला है? सीमेंटेशियस मटेरियल, मेरा वाटर सीमेंट रेशियो और कॉम्पैक्टिबिलिटी विद द एडमिक्सचर।
यस
जो आपने अक्का 3 घंटा का जो लेक्चर या 2 घंटे का डिटेलिंग दिया, वही उसको हमको बेसिक पकड़ के चलना है।
यस यस
तो
यस
ये जो चीज है, दो चीज, व्हेन आई एम टॉकिंग अबाउट द IS 1062 या EN कोड ले रहा हूँ या मैं ASTM ले रहा हूँ, तो बहुत फर्क पड़ जाता है। और यही है जो 25% वाटर रिडक्शन, 30% वाटर रिडक्शन, 40%, ये सब चलने वाला है। इसको हर
चलने वाला है।
एक मार्केटिंग गिमिक, हर एवरीबॉडी इज सेइंग दैट मैं सीमेंट इंडस्ट्री आता हूँ, मैं सीमेंट का बात करूंगा। somebody comes with the admixture,
ये वो लिटरेचर में भी लिख देते हैं 40%।
एडमिक्सर वाला कभी ऐसा नहीं बोलेगा मेरा सीमेंट सब सीमेंट को कॉम्पैक्टेबल है। सीमेंट वाला भी बोलेगा मेरा सब मेरा सीमेंट सब एडमिक्सचर, सब क्रश सैंड, एग्रीगेट, वाटर, एवरीथिंग सबको कॉम्पैक्टेबल है। और यही है कि एट द एंड ऑफ द थिंग सब कुछ चल के देयर आर सो मेनी इनकम्पैटिबिलिटीज इश्यूज आर देयर।
यस यस
तो
यस
होना
बाजी, आई एग्री।
एवरीबॉडी इज सेइंग दैट माय मटेरियल इज गुड, तो तुम्हारा अल्टीमेटली फाइनल प्रोडक्ट जो RMC का बनता है उसमें प्रॉब्लम्स क्यों क्रिएट होता है? तो ये थोड़ा सा
10262 में जो आपने बताया एकदम करेक्ट बताया। 10262 में रिटेंशन की बात ही नहीं की है।
एब्सोल्युटली।
खाली एक पर्टिकुलर स्लम्प, आप कभी भी कोई भी एग्जांपल ले लो, उसमें लिखा है कि 75 mm स्लम्प 2 घंटे के लिए है, 3 घंटे के लिए है, शुरुआत के लिए है, क्या है भाई?
करेक्ट, एब्सोल्युटली
शुरुआत में मैंने 75 रखा तो 3 घंटे में तो वो माइनस स्लम्प नेगेटिव हो जाएगा।
और लोगों का आइडिया, लोगों का फंडामेंटल ऐसा रहता है कि ब्लीडिंग नहीं होना चाहिए। अरे जब मैं 650 फ्लो मेरे को चाहिए 3 घंटे के बाद, तो तुम मेरा सेग्रीगेशन पहला क्यों देखता है? अरे 1 आवर 2 आवर को मेरे को देखना ही नहीं है। आपको क्या, मैं आपको देना चाहता हूँ 3 घंटे के बाद या 4 घंटे के बाद, तो यू शुड फोकस ऑन टाइम पीरियड। बस वो टाइम शेड्यूल चेक करके बात करो। वो 3 घंटे के पहले मेरा प्लांट पे सेग्रीगेशन है या ब्लीडिंग है या मेरा स्टिफ है मटेरियल, उसके कोई लेना देना नहीं है।
नहीं देना नहीं है।
हाँ, तो फंडामेंटल्स क्लाइंट का भी अलग हो जाता है, फंडामेंटल्स एडमिक्सचर वाले का अलग है, फंडामेंटल सीमेंट वाला है। फ्लैश तो उसको कोई क्या बोलता है, माँ बाप कोई नहीं है। जो मिलता है एवरीबॉडी इज पुटिंग द 9% रिटेंशन, 40% रिटेंशन। उसका डिजाइन ही कुछ है और फंडामेंटल कुछ अलग है। तो क्या हम बात करेंगे? ऐसा हो जाता है कभी कभी। वी फील दैट अरे क्या इतना सब थियोरेटिकल चीज कैलकुलेशन करके एंड ऑफ द थिंग कहाँ हम पहुंच जाते हैं।
Exactly.
साहू सर प्लीज आप कुछ
dear friends, thanks to everyone for attending this one. Very nice presentation and excellent discussion, I can say. The discussion is really taking place in very nice way, and really everyone is going well. You can say mixed designers, admixtures, plant, cement, everything is fine. Only I request more to the RMC people. You kindly have so many mixes. Don't use one mix for M30 for 2 years. That is the main fault actually. Whenever you are changing anything, coarse aggregate, fine aggregate, admixtures, anything you want to change, you have to get your mix design verified actually. But in practically, I am finding if some project is going on for 3 years, they are supplying same mixed design ratio, whatever they are using, and in between in 3 years they are changing at least 10 sources for sand, for coarse aggregate, even admixtures also they are changing. So kindly get proper design mix. Don't blame to cement or don't blame to admixtures company. More responsible is the your mixed design, because they will provide whatever admixtures you need. In mixed design only you have to check what is the percentage of that admixture, what is the desired, you say 2 years 2 hours retention or 3 hours retention. So there is the clue actually where we are lagging actually. We are reluctant to have at least a 10 mixed designs for say M30. If I am knowing that I am going to use 10 type of different sources, I should have 10 type of mixed design, not only 1 or 2 actually. So main culprit is that one, and we are blaming one and other. Yes, Corona come from India, China, or Pakistan, Singapore, USA, like that. We are just throwing ball from here and there, and we are not realizing we are the main culprit actually, who are using only one mixed design for all type of resources you are using. So that is the main problem actually. So let us come to the in a uniform way. We will
Yes, sir.
use proper mixed design, and really then only, otherwise say all people are blaming. Yes, whenever there is a say less strength, people are blaming. Yeah, RMC प्लांट वाला ठीक नहीं है, वो
हाँ,
कुछ भी मिक्स दे दिया. वो ये भी नहीं देखेंगे कि उन्होंने कॉम्पेक्शन नहीं किया, क्योरिंग नहीं किया साइड पे, बट दे आर स्ट्रेट फॉरवर्ड यस टेलिंग. देन RMC प्लांट people will straight forward tell to the admixture company, you have not provided proper admixture. So we are blaming one in each other. We are all are in queue actually. We are contributing everything that contractors, that admixture, RMC plant, everyone is responsible for that. So we should work in a team. Then only we can solve the problem. Otherwise, this problem will continue. And really, for infrastructure, what we are going to create day by day, it is very difficult to maintain. One day will come when we will not get any budget for maintenance. We are just creating so many structures. You see, infrastructure wise, really very good
Yes.
growth. But you think after 20 years or 25 years, how we will maintain? We
yes,
are
sir.
thinking that this will go for 100 years. But when I am visiting, I have visited around 1,000 bridges. Out of 1,000, we will find 950 is in some stage of distress. Some are in ICU unit after 10 years, 15 years. So you can think, really, we have to come together and let us solve this problem so that we can save our nation infrastructure. Thank you, everyone. Really, I enjoyed this presentation and
Thank
this
you, sir.
discussion.
Thanks.
Sir, thank you
Thank
for
you,
your
everyone.
golden words.
Thank
Thank you
you.
for your golden
Thank you.
words.
Thank you, everyone.
What my
And
intake is that professional compatibility is more important.
yeah, definitely. So
All
I
this
request
is
really nice presentation, and I
incompetent.
request
Yeah.
in many forum, Kargupta ji, you have to come and just to ignite between people. Yes, this is the region, and you have to go in proper path. This should be really propagated.
Will be done,
Thank
sir.
you.
Done, done,
Thank you.
done.
Thank you, Gupta ji.
Thank you, sir.
Even
Thank you.
Sanjay
Thank
ji,
you.
you have really explained good. And in between things have also there's some question. So this type of question really very much useful.
Thank you, sir.
Thanks
Thank you.
everyone.
Thanks. Thanks.
So now we come to the closing. I would request our president Sudarshan Sharma ji to please give a closing remark, and then we'll wind up. Sudarshan sir, please.
Thank you very much. Good evening, everyone. It is a great pleasure for me to say a few words at the end of this tech talk. First and foremost, I would like to express my deepest thanks to eminent speaker, Engineer Nirmalendu Kargupta, sir, and panelist Sri Satish R. Bachani, Engineer Dhruv Chaudhary, Engineer G.K. Sahu, and Engineer Sanjeev Rajesh, sir, etc., and their valuable contribution to our tech talk on incompatibility issue of chemical admixture HRWR and UHRWR with cement and how to mitigate them in concrete. My deepest gratitude goes to who attended the tech talk and helped to make it such a successful event. Hearing and learning from speaker about the incompatibility issue of chemical admixture. As we all know, the behavior of concrete in the presence of superplasticizer is related to the amount and type of sulfate added to the clinker. The rheology and setting behavior are changed depending on whether the sulfate is added as anhydrite, hemihydrite, or gypsum. The difference are explained by the different rate of dissolution of the result sulfate. It is also important to note that all admixtures belong to the same generic type may not behave similarly in concrete because the variation in the molecular weight, cation, association with them, chain length, etc. Similarly, the same type of cement generically may be different in mineral, alkali, and sulfate content and fineness. Kargupta sir has elaborated very knowledgeable this presentation from the beginning about the generation difference between the absorption and adsorption, explanation, calculation, type of chemical used to prepare the admixture with their chemical name, type of air, micro and macro, repulsion due to the positive as well as negative charges due to the steric repulsion, not due to the coulombic repulsion. What is the incompatibility, type of gypsum, alkali content required for reaction, harmfulness, or calcium sulfate hydrate, understanding for performance indicator, describe over retardation, poor slump retention and dispersion, and many other things. Before ending my closing remark, I would like to convey a special thanks core committee, Mr. Ramanjit Singh Balia, Mr. Himanshu, Mr. Dhruv Chaudhary, Mr. Sanjay Gupta, G.K. Sahu sir, who have worked behind the scene very hard and aggressive to make such a wonderful event. Finally, my deepest thanks to eminent speaker and participant and attendees for their peaceless contribution and for running the smooth event. Thank you very much, everyone.
Thank you so much, sir.
Thank you, sir. Thank you.
Thank you to the
Thank you, sir.
Thank you, sir.
Yes.
Thank you. We are now closing. Eh?
Thank you, sir.
We are now closing.
We loved
In
it.
case any other questions are there, you can mail us on the email ID which sir has given, admin@concreteengineers.org. Right. Thank you, sir.
Thank you.
Thank
Thank
you
you,
all.
everyone. Thank you. Good
Thank
night.
you all. Thank you, sir.
Good night.
Thank you, sir. Thank you.